the previous chapter, you finished building the invoices routes by adding form validation, improving accessibility. In this chapter, you add authentication to your dashboard. What is authentication? Authentication is a key part of many web applications today. It's how a system checks if a user is who they say are. A secure website often uses multiple ways to check user's identity. For instance, after entering your username and password, the site must send a verification code to your device or use an external app like Google Authenticator to it. Authentication helps in increasing security. Even if someone learns your password, they can't access your account without your instructions. In web development, authentication authorizes serve different roles. Authentication is about making sure the user is who they say they are. You're proving your identity with something you have like user and password. Authorization is the next step. Once the user's identity is confirmed, authorization decides what parts of the application they are allowed to see. So authentication checks who you are, and authorization determines what you can do for accessing application. Creating a login log. Start by creating a new browsing application called login. You will notice the page in your login point. This will update in the later chapter. We will use Next.js to add authentication in your application. Next.js abstracts away much of the complexity involved in user sessions, sign in and sign out, and other aspects of your authentication. While you can manually implement the features, the process can be time-consuming and error-prone. Next.js simplifies the process, providing a unified solution for authentication application. Setting about JS, install Next.js by running the following command. Here you are installing the beta version of Next.js, which is compatible with Next.js 14. Next, generate a secret key for your application. This key is used to encrypt cookies, ensuring the security of the other user sessions. You can do this by running the following command in the terminal. For to work in production, you will need to update your environment where you run virtual project to. Check out this guide on how to add environment variable. Adding the pages option. Create an auth config TS file at the root of your project and export an auth config object. This object will contain the configuration options for Next.js. For now, it will contain the page options. Next.config. I'm adding a pages option for signing out. Will contain the configuration options for Next.js. For now, it will only contain the pages option. Okay, you can use the pages option to specify the route for custom sign in and sign out and error pages. This is not required, but adding sign in /login into your pages option, the user will redirect to a custom login page rather than the Next.js or default page. Interesting note how to use this. Let's add the logic support to routes, which is prevent users from accessing the dashboard pages on their cell The authorized callback is used to verify if the request is authorized to access the page. By Next.js middleware, it is called before an request is completed and receives an object with the auth and request properties. The auth property contains the instruction and the request property contains the request. The provider's option can add array where you list different locations for marketing to satisfy the needs. We'll learn more about next we need to import the auth and the object into the file. Kino where were we? Next you will need to add the input auth config object to the middleware file. The root of your project, create a file called middleware.ts. And paste the following code below. So import next option, next option 3. Enhancing both security and performance of your application. Nice. What is this one? Password hash. It's good practice to hash passwords. Before storing any data platform converts a password to a fixed length of string or characters which appears a random, providing a layer of security even if the user data is exposed. In your C.js file you use the package called Decrypt to hash the user's password before storing the errors. You will use it again later in the chapter to compare the password entered by the user manually one in the database. However, it is need to create a separate file for the Decrypt package. This is because Decrypt relies on the API, not available in Express. Create a file called auth.ts that splits your auth config object. Okay. Then add the credentials provider. Next we'll need the providers options for NextJS providers. Is an area where you list different login options such as Google or GitHub. For this course we'll focus on using the credentials provider only. Okay. Although you're using credentials provider, it is generally recommended to use alternate providers such as OAuth or email providers such as Next.js for a full list of options. Okay. Adding the sign function, you can use all such functions. To validate the email password, user checking if the user exists through the database. After validating the credentials before you can use a function that queries user from the database. Get users from here. Try user, await SQL user. Nice. Okay. Then call bcrypt compare. Okay. Understood. Finally, if the password matches, you want to return the user, otherwise return null to prevent users from logging in. Select star means you return the user, where email is that. Updating the local form. Now you need to connect the auth logic with the login form. New action.ts file, create a new action called authenticate. Well, action. Authenticate here straight from it. Okay. Sign in. Oh, nice. You need to connect all logic with your login for new action.ts. Create a new action called authenticate. This connect this action should import the sign function from auth.ts. If there's a credential sign up error, you want to finally in your login form that component you can use action script for the action server, action handler, form errors and display. Yes, as it's client side thing. Adding the logout functionality to add the logout functionality to SideNav, call the signout function from auth.ts in your forms element, sign out from auth, then in action use server await signout. Okay. Wait, what? This is going to slash login every time. I don't know, man. Hey, yaar. अरे यार बाप रे. Oh, there's more. Damn. Totally doesn't. E-commerce, SaaS, data, visual editing, photoshop, blog starter. Damn. Let's learn WebSocket today.
What is going on, guys? Happy New Year. This is a very small gift from me to you in this 2021. This was one of my Udemy courses. It's called The Complete Guide to WebSockets, and I'm making it available here for free on YouTube. It's a little bit more than 5 hours. Take your time, enjoy. And the reason I'm not making that free on Udemy, because guess what? Udemy sucks as a platform, and they changed their rules. So that only 2 hours, you can only make courses that are 2 hours or less free. So alas, anyway, so that's why I YouTube. It's a little bit more than 5 hours. Take your time, enjoy. And the reason I'm not making that free on Udemy, because guess what? Udemy sucks as a platform, and they changed their rules so that only 2 hours, you can only make courses that are 2 hours or less free. So, alas, anyway, so that's why I privated that course on Udemy, but it's now available here for YouTube, in YouTube. Hope you enjoy, guys. And so let's talk through about the curriculum of this course a little bit. First of all, there will be, and you'll start seeing chapters, YouTube chapters, where you can jump to the interesting part of the video at any time at your leisure. So the first section is just an introduction to HTTP and web servers, stuff like that, because this is very critical in order to understand WebSockets. The second section talks about an introduction about WebSocket. What is this thing? Why do we need it? Stuff like that, with a little bit of practical slides and code and all that stuff. The third section talking about scaling WebSockets, how we can actually you deploy reverse proxies and load balancers to scale WebSockets, because that's a little bit tricky since WebSockets is a little bit stateful, so it's not easy to scale, right? And then the next section, I'm going to talk about securing WebSockets, because a little bit different than HTTP, but nevertheless it's very easy to secure. You can use TLS on top of WebSockets. Then I have a final section which I called Advanced WebSocket Topics, which is just a collection of my different YouTube videos where I talked about WebSockets and the future of WebSockets, and then the advanced topics of WebSockets, like WebSockets on top of HTTP2, and what's the future of WebSockets, and how does WebSocket really look like under the hood with Wireshark. So all these fancy stuff that are really optional, but I hope you enjoy this course. I'm gonna see you in the next one, and let's just jump in the course. Cue in.
HTTP is a protocol for transferring web pages, text, images, media, binary files, and much more. It stands for Hypertext Transfer Protocol. It is text, images, media, binary files, and much more. It stands for Hypertext Transfer Protocol. It is what the internet pretty much runs on. Everything you see in the internet is pretty much runs on the HTTP. In this video, we will learn how HTTP works, how it is secure with HTTPS, this green lock that you see when you browse, for example, Google or Gmail, right? Or any website that is secure for that matter. We'll also learn how to spin up your own HTTP web server. We're going to talk what is an HTTP web server to begin. We're going to talk about that. We'll also learn very quickly about the evolution of HTTP, starting from 1.0, what changes, what bad decisions those guys made, to 1.1, and then HTTP 2, which Google basically helped with Speedy, and eventually HTTP/3, which is still experimental, by the way, as of the making of this video, right? Has been, I think, approved by the Internet Engineering Task Force, but is still under experimental. If you're new here, welcome. My name is Hussein, and in this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing, hit that bell icon, and like this video if you like it. That's it. Let's just jump into the video, guys. So here's the agenda. We're going to talk about the HTTP anatomy, right? So essentially this layer 7 concept, right? And how it is actually a client-server architecture, mainly. And we're going to talk about that a little bit. We're going to show you how a HTTP request looks like, how a response looks like, and then we're going to talk about the HTTP 1.0 over TCP. Okay, so that's the first version. I think it was 1996 when it was first released. There was a version before that, but I'm not going to go through that. That's like pretty much that was the popular version, 1.0. Then there was a lot of problem with this thing. They invented 1.1, still for a long time, 1.1. Most of the sites now running still 1.1 over TCP. I'm going to talk about that mean, really, over TCP, right? And HTTP 2 over TCP, and finally we're going to talk about HTTP 2 over TWEC, which is a UDP version that Google is experimenting with. So it's a UDP protocol, okay, and it actually has more features, right? And I'm going to reference a video that we made, TCP versus UDP. I really highly recommend you watch that, guys. It's like a mini course, 40 minutes. It's free. You can watch it. And I talk about the details of TCP versus UDP, and I really, if you know the basics, you can jump into the video. That's okay, but really take some time and watch that, TCP versus UDP. This is the experimental version. They were renaming it to HTTP 3. All right, so it is client-server architecture. We know how client-server architecture works. There is a client somewhere. There is a server somewhere. You, as a client, request something that is only available on that server. You send a request. The server responds with a response. Okay, that's a client-server architecture. For the web, for the HTTP, the client is, guess what? Your browser. Most 99% of cases, like you are browsing something, right? If you go to google.com, you're making an HTTP GET request, okay? And there is eventually a server that lands. That request goes through proxies and switches and go through TCPs and get packets. Finally reaches the destination server where it is an HTTP web server, okay? That finds that request. You want indexed HTML, you want a JSON file, you want an image, and that takes that, shoves it up back to this vehicle, which is mostly TCP, and then sends it over to you, okay? It's a client server. It's a request response architecture. It's always been the case, okay? Does that mean that's the only thing I can request with browser? No. You can make a HTTP request from Python. You can make a HTTP request from a JavaScript application. You can make an HTTP request, and you are actually making an HTTP request from your phone. If you're watching this in your phone for some reason, iOS or Android, you're making a HTTP request to the service, right? If you're watching through YouTube, for example, there are some HTTP requests going to the back end, okay? So HTTP request essentially is this medium that we just shove everything. It's a standard. Everybody knows how to understand it, right? And how to talk through it. That's why we are using it everywhere. There are some limitations. We're improving it. Google has huge contribution. It's actually almost scary how a lot of contribution has Google on this thing, okay? Like especially with Speedy, with 2.0 and 3.0. It's like almost most of the thing is just Google's gonna take over the world, dude. All right, so server. I don't know if you're from the 90s like me, right? When I started the university in the 90s, you probably used Apache somewhere, right? PHP, right? The LAMP stack or WAMP stack. We didn't have Linux back. I worked with Windows mainly, but LAMP stack, WAMP stack, whatever, right? So Apache, that's a web server. IIS, there's an Internet Information Services. That's a Windows thing that comes with your Windows. You can enable it from Windows features, and you get a web server. You can write your own web server from scratch using Node.js. There's certain APIs that allow you to do that, right? And there's like when we're going to show that, you can actually build your own, you can just use a ready-made web server in Node.js. We're going to use a HTTP-server to show that. Python Tornado. I made a course called Python on the Backend. Little plug here, guys. Check that course out. It's just showing you how to build a web server using Python and details about how you can serve content from Python. I'm really proud of that course. Go check it out. It's gonna help me, right? I'm gonna leave a coupon code right here. Python on the back end. I think it's like around $10. Don't buy it from Udemy. It's just gonna show you like $200 or whatever. So use my coupon code if you want. If you want to check out that course, right? HTTP request. If you want to make a request, these are the 4 items, properties in an HTTP request. There are many others, but I would like to just talk about these things only, right? There's the URL, obviously, right? You're going http husseinnasser.com, http google.com, right? Example.com, that's a URL, / whatever, twitter.com/hnasser, that's a URL. The URL has a lot of components. It has like the whole path, the arguments. All right, we don't really need to talk about that. I made another video. I'm gonna reference it here, just breaking down the URL. Really, yeah, it's a long thing. Okay, it's just URL. You're making a request, you have to tell me what URL. You have to tell me what method you're talking about. And these methods are really interesting. I made certain videos like to explain the differences between these detailed methods. Mostly get, post, put, delete, and I think options. And there are a lot of HTTP methods. And each method has some semantic. Get mainly says, hey, please give me a page or an image. So reading, essentially. It's like almost like if you know SQL database, there's like this semantic where select is actually a query, right? Get is the select version of the SQL if you want to. All right, and insert is basically post, and update is basically put, and delete is basically delete, right? So that's kind of, if you want to, it's just different semantics, right? We made a video about get versus post and the details differences semantically between those two, okay? But you gotta tell me what do you want, right? What method are you executing, okay? And then URL, method, right? Because these two things will give you essential results. Headers, what kind of content are you sending to me? Are you sending any cookies? It goes in the headers. What else? It goes a lot of things here. Host, which host are you going to in case of proxies, right? You want to, if you want to use a layer 7 proxy and to kind of navigate yourself, you need to put the header host here and location, other stuff as well. Body. Certain method types have body. That's where the difference comes right here. Like get doesn't have a body. It will give you an error if you try to send a body with a get. You have to send it through the URL, and we talked about this in the video, get versus post, right? And post will have a body because, hey, I'm gonna upload an image. That's a post, right? Okay, and the post request, you're gonna send the content type of the image, and then you're gonna send the binary stuff in the body. So it's gonna be long, right? The body. HTTP response. I am going to hopefully make a series about all the beautiful status codes that there are. Hopefully, and I'm just gonna talk through one video as each status code or one video. I'm gonna make a series. I'm really excited. Tell me in the comment section if you're excited to see that series, so I get motivated to make it sooner. Okay, but I'm gonna make it anyway. So static code. This is, guys, you probably know it. If you make a request to a web server, it responds with three things: status code, headers, and the body. So the body is the actual image that you requested, the actual JSON content, the actual index.html file or HTML file. Headers is, hey, this is the content type is actually application/JSON, application/text, whatever, application/octave binary. Status code is actually whether that succeeded or not, or warning, or all this kind of things. 200 is basically, hey, success, okay, that means you're cool. 201, that means, oh, hey, you created it. 404, it's very popular. Status code is pretty much used everywhere. 404, I couldn't find that URL that you requested. Whatever you requested here, I couldn't find it, so we return 404. And the web server has to be authored in a smart way to actually handle those things. IIS, Apache, pretty much HTTP server, Node.js is gonna do that for you. But if you're writing your own web server, right, which we kind of did in one of those videos, I'm gonna find it, I'm gonna reference it here, okay? Then you have to handle those status codes for you, which is pretty cool if you ask me, right? So if you're creating, like if you're building a service, like a normal service, a web service, a microservice, right? You want to handle your own status codes, right? You're writing everything from scratch, right? You're making a request, you're getting a request, you have to return, and you tell me that what kind of status you're returning based on that. So the client actually understand. Other clients understand. All right, let's show some example, guys. We're gonna show two examples. We're gonna show you how to browse, because you guys obviously don't know how to use the internet. I'm gonna show you how to navigate the internet and just browse using the browser, okay? Because that's what you came for this video for. I'm just kidding. All right, we're gonna show you the browser, gonna show you the request that's going on, all right? And we're gonna show you how to spin up your own HTTP web server, okay? Let's get into it. I here opened Chrome, and I just went incognito just so I don't have any caches or anything, right? So I want to just start from scratch, and I want to go to my website, which is www.husseinnasser.com. Can't even spell my name, okay? And this is the request that we made. Okay, we went to husseinnasser.com, and this is what we got back. Okay, let's analyze that. If you go to this three dots, right? I think it's called burger button, whatever. More tools, developer tools. Let's see what happened here. You go to network and you say, if you go after the fact that your browser, you're not gonna see anything, but if the moment you refresh, you're gonna see the all those requests. Oh my God, look at that. Look at that. My website actually sucks, man. I'm using Blogspot and look at all this. This request, this is slow, right? Because you're making a lot of requests. But that's the first request goes here, okay? And let's talk about these things real bit, okay? That's the request, okay? So we made a request to HusseinNasser.com, right? Let's look at the request headers. What do we have? We have a lot of stuff, guys. We are going to HusseinNasser.com. The method that we talked about is get. The path, the URL is just slash, right? Whether you're using HTTPS, we're going to talk about a little bit about HTTPS. Actually, we talked about TLS and in another video. We're going to reference that as well. But what do you expect as a result? Okay, encoding and cache, whether you want to cache it or not, and so many other things, the user agent. So this is a request, right? The response is the actual, the response headers, right? Say, I'm sending you back what? Text, HTML, because that's the index.html or whatever the page was. As you can see, you can even tell that I'm using Blogger, right? And the date, ETag for caching. We made a video about ETag. I'm going to reference it here, how caching actually works. Pretty cool stuff, really, guys. And the status, 200. That means it is coolish. That means it is coolish. And this is just like a general summary of all the requests, right? So we have status 200, get, and all that stuff. Remote server, like what is the remote address that actually served you? This could be a little bit different, because it could be actually, it might be the proxy IP address, but nevertheless, right? Cookies, whether you have used cookies, whether the server created cookies, guys. I referenced a lot of videos. Like we made a lot of videos. Cookies, we made a course about cookies. Actually, it's just a free course. Check it out. It's just talking about the different kind of cookies. You would think a simple concept like cookies is a simple thing, but it has a lot of things, and we talked about that as well. And the response, look at that. That's our HTML file. And you can see this is just the first request, guys, right? After that, after we got that, we got a bunch of index.html, and the browser says, ooh, there's a lot of URL here, right? I need to stop pulling some stuff. So the browser said, oh, let's go ahead and make other requests. Started with CSS for some reason, right? So it looked at the first thing, it looks at the headers of this thing, right? And started pulling one of them one by one manually. Oh, CSS, let's put the CSS. And then the +1.js. Where's this thing? +1.js. I don't even see it, but it's somewhere here. Okay, so start pulling all these files or resources. Okay, now let's make another GET request to blogger.com/CSS, right? +1.js, and then images. And then let's talk about images. How does the image looks like here? Yay, the content type. Look at that. Image PNG, right? So you're gonna receive different response things here. And some of these will get cached based on your e-tags, right? Right? If you receive an e-tag or not, it's gonna get cached. so the browser doesn't have to make these requests. Obviously, it's more performant this way. And then you get the idea, right? So we get a lot of requests. Do we have any other kind of status codes that I can show? Maybe if I refresh again, do I get any fancier status codes? No, it's all, yeah, there you go. There you go, 302 found, right? So I don't remember what that means. 302 found. Obviously, it's found. I think this is the redirection thing. There was another request that actually shows the 204. There you go. What is this? 204. So 204. Yeah, I forgot what that means. Okay, guys. All right. So this is a request. We talked about request. We talked about response. How do I spin my own web server? This is connecting to a server that already exists. I want to spin my own. Servers, sir. Okay, let's show you how to do that. What I'm gonna do here, guys, is actually this is connecting to a server that already exists. I want to spin my own servers, sir. Okay, let's show you how to do that. What I'm gonna do here, guys, is actually I'm gonna open Visual Studio Code. You can download it for free. It's the best editor out there, in my opinion. Okay, you can disagree with that if you want to. And I'm gonna spin up, and I'm gonna write a simple HTML page, and I'm going to spin up my own web server on my machine, and I am going to request it from the browser. Let's do that. Okay, let's go ahead and open a new folder. All right, guys, I'm gonna go ahead and create a new folder, call it HTTP tutorial, and then I'm gonna open this folder. I am going to create a brand new index.html. It doesn't have to be index.html, but you can call it anything you want. I'm gonna do HTML5 tab. I'm gonna go hello world. I'm gonna do it. I don't know. Hello guys, this is my first website. Then yeah. Right, and then I'm gonna use the terminal here, and this is a trick here. I have installed a plugin with Node.js called HTTP Server. You can go to the same path to the folder that you have, and you go to terminal. Then when you do that, you do HTTP-server. I'm gonna reference a video that is like literally a 3-minute video to show you how to set up this thing. It's literally install Node.js, do I think it's called npm install-g HTTP-server to install it globally, and then voila, we have running web server on port 8080. It's a little bit ugly. It's not just without a port, but we talked about how to forward ports and on other videos. Check out the other content of this channel, guys. There's a lot. If you consider subscribing, you're gonna learn a lot of stuff. So I'm gonna use my own IP address, localhost 8080, and if I do that, oh, that's my beautiful web page. Look at that. Let's take a look at the request. should be one request, right? That's it, one request. There's no other thing to request. And then there's like, these are the requests that Chrome sent. You can make the same request using the Fetch API, which we talked about. The Fetch API, I'm going to reference it here. So let's go ahead and actually show you how to write JavaScript code to actually pull, not necessarily the browser, right? But I'm going to write code to pull this thing. Okay, so I'm going to do HTTP localhost 8080, the Fetch API, and then close this thing. And then if that's okay, go ahead, and I'm expecting text back, right? And then go ahead, then console.log, just printed that thing, and then boop. Look at that, guys. So I just made a request using JavaScript here, because JavaScript is the best language ever. Yeah, because you can open a browser on any machine and you can write code immediately. No plugin, no have to install anything. It just works, right? That's why I like JavaScript. Okay. Yeah. Python, it's a great language, but that barrier that it doesn't allow me to work on any machine I want. This thing, any machine, just walk in a library and you can start writing JavaScript code right there without installing a single anything. Okay, that's the cool thing about it. Okay, all right, guys, let's jump back to boring slides. How about that? All right, so we talked about HTTP responses, requests, web servers. We showed you how to make a fetch request. We showed you how to make a web server, spin up your own web server. We did all of that stuff. But how does it work? How does it really work? How does this HTTP work? Usually you have a client. That's your browser. Or that's your JavaScript application. Or that's your Python application. Or that's your, I don't know, C# application that makes a request, that your mobile app, that your iOS app that makes a request to a server. You get the idea, right? And this is an AWS or the web server or anything that hosts a web server, an HTTP web server. Has to be an HTTP web server, understands how to deal with HTTP requests, okay? And here's what we really need to talk about here. HTTP is the layer 7 protocol. So what does that mean? What are these layers that you talk about? I'm glad you asked, because we made a video about this OSI model, Open Interconnection Protocol and model, which has this layer. Layer 7 is the HTTP, SMTP, and all that stuff. We have layer 4, which has the TCP, UDP. We have layer 2, which has the data link, the frames, the MAC addresses, and physical link. Layer 1, which is the actual fiber optics or Ethernet, the actual electricity going on, or the light. Okay, so we talked about this in another video. I'm going to reference it here. Okay, I'm going to reference the OSI model. Please take a look at it. So it will actually explain to you how this TCP connection works. How is this Russian doll effect, where we can put a packet inside another packet inside another packet and then unpack it and shows another thing. It's exactly like a Russian doll thing. HTTP is this layer 7 protocol. It's the logical layer where we have the application, where we talked about headers and what? We talked about URLs, we talked about method types, we talked about body. The wires, the actual internet connection, if you look at that layer 1, it's just a bunch of ones and zeros. And you probably know that, guys. It's like, okay, I know this is ones and zeros, saying you didn't see anything new, right? But it is actually a bunch of ones and zeros, but that's at that level, it is actually literally, it's just electricity, to be honest, right? Or just light. And that light has some ones and zeros snuck into it that only the destination actually can parse and make sense of it. There's a lot of garbage, so there's the devices that switches actually just can extract meaningful data of this light and electricity. Once we do that, the layer 2 that actually makes a logical frame, which still doesn't make sense to this application, because it's a still ones and zeros, but it has metadata called MAC address, which is a physical network layer, network address. Okay, then upper level IP address. Oh, I know what an IP address is. At the layer 3, you start seeing IP addresses, and the layer 4, you start seeing even more cool stuff. You start seeing the ports, port 80. I don't think if we talk about ports, but ports essentially is the application level concept, right? Once you see at the TCP layer, you start seeing these ports. Okay, and then we're going up the other layer, this encryption layer, session layer, and then go all the way and then unpack all the dolls, the session doll, until we found a bunch of blob string that actually looks like an HTTP request. TCP is the vehicle that transports this blob of string for us, the HTTP that we talked about, right? It's just blindly transport this thing. It has no idea what it's transporting. It's a stupid layer. It is a smart layer. I'm sorry. It is a smart layer that does its job very well. Okay, let's rephrase it. Okay, but it's just like a bus. Just like a bus. Send me data. I'm gonna receive it. I'm gonna send it. I'm gonna send it in a way that it is received correctly at the other end. and we talked about TCP and UDP. TCP is a little bit expensive because to ensure this integrity, it has to do a lot of stuff. It has to do a lot of stuff. Okay. And congestion control and all that stuff. But TCP, it uses TCP in a nutshell. Okay. That's what I want to talk about. So a TCP as this vehicle is the bus that carries this data around. Okay. So it just chunks this data and then into packets and then shove this data into TCP and shit. But to start the TCP connection, we really need to essentially do some sort of a handshake first. Okay. We have to like essentially a three-way handshake. Okay. Open a connection. To open a connection between the client and server. And that's the first thing we do. We open a connection because we're about to send a GET request. We're going to HusseinNasser.com, right? And we're going to that site. And the first thing I do, get/HusseinNasser.com. That's the only thing I sent. Okay. This string of thing will get converted into bytes, and this bytes will become such a bits, ones and zeros, TCP, and then will get sent across to the server. And then the GET request will be received by the server, and the server will process this request, make sense of it, responds with the headers and the index.html, send it over to the TCP connection. This could be one package, it could be multiple packets if you have a lot, right? Because TCP just breaks things down. Okay, but that's the idea. Make the request, send it back, close it. That's what HTTP actually does. Okay, we're gonna talk about the differences, little bit differences here between 1.0 and 1.0. But that's the thing. That's it. Open TCP, close TCP. That has a cost. Open and close. Okay. HTTPS. It's exactly like HTTP, but there is something happened at the beginning. It's called a handshake. It's a TLS handshake or SSL handshake. And we're going to reference the video that we made on TLS, guys. Talk about how we actually establish a secure communication. So all of the reason of this handshake is for those two to have the same key. That's what it is. TLS. And we talked about the details. We actually zoomed in this thing and we talked about it in details in that video. So I'm not going to go into that in there. But essentially, the goal of this is let both parties have a key, the same key, symmetrical key, encryption, okay, and then let them exchange it. Now, if the client wants to send, essentially encrypts, but to encrypt that, send the request, get request, and then the server will actually, if someone starts to sniff it, it will not understand it. Take that request, response, encrypt the response, send it back, and then close the connection, okay? Now, we talked about HTTP, talked about HTTPS. Now, what is HTTP 1.0, the first version, 1996? For some reason, okay, it was a good idea, right? So, remember, guys, this is 1996. RAM was what? I think the maximum number of RAM was 64 megabytes right back then. I think that's the first computer I got. Right, so TCP connections, establishing a TCP connection was expensive in terms of RAM because each TCP connection takes some memory, okay? And we didn't want to leave all these TCP connections open. So what we do, we thought that we are smart back in 1996 and said, okay, for each request, we're gonna open a connection, send the request, response, and then once we're done, we're gonna close the connection. And we thought it was a great idea. We thought it's a brilliant idea. But then index.html, that's when we had what? Like the index.html had what? Well, like text, and that's it. Like this web 1.0 pages where it had like marquee text and what this blinking things and you know the 1.0 1996 kind of websites if you're from that era, right? So it doesn't have a lot of stuff. But as the internet became more popular, people start putting images in their index.html. People start doing a lot of stuff. So this index.html has a lot of stuff. So guess what? That's not the first request and the only request we're gonna make, right? Yes, you just close the TCP connection here, right? By the way, the TCP connection is actually both sides, right? So this is here, and there's another one here. So I just didn't show it. But that's the most critical one, the one that is here. That's the memory. So we close it, so we reserve the memory, and then the memory can be used for something other thing, like playing Minecraft or where Minecraft wasn't invented in 1996. never mind. Playing Prince, if you guys know that game, Prince of Persia. So close that thing, and then guess what? I'm about to send another request because there's an image. That user needs to see that image. I have to request it at some point. So go ahead and open another connection. Request that image 1.jpg. The server will open that connection on that side, and then responds with the image. And then guess what? We close it again. And then, hey, by the way, I forgot. There's an image 2. And then we close it. You can see how expensive this gets, right? If you watch my TCP versus UDP, TCP is very slow to start. It is literally, there's a problem called with TCP called TCP slow start. Okay, because it has to do a bunch of things. And TCP is slow in general because sending it has to do all this congestion control, reordering packets and all that things, and making sure everything is in order. So that's very expensive. So HTTP 1.0 didn't last a year. Right, 1997 is like, that doesn't make any sense, guys. We really need to fix that. Right, so we'll see how to fix it. So it establishes a new TCP connection with each request, which is slow. And what it does, like, it is buffering the responses, okay, at the back end. So if you have like a large results, like a huge index.html, what it's gonna do is will literally buffers wait for the server to build all that index.html and then sends it slowly to the service. Okay, HTTP 1.0 a little bit improved on that using streaming, but instead this is using buffering. Okay, 1.1, our problems are solved. This is the only protocol that survived what, 20 years? Because 2015 HTTP 2 became the dominant ones. I don't know if it's still dominant or not, but 2015, let's do the math. 2015 to 1997, that's 20 years, oh, more than that even. Okay, this guy survived 20 years. Okay, and it invented something called keep alive header. So it's a header, but the server, it's a server, the header for the server to know that, oh, I probably shouldn't close that connection, huh? Right? So we open a connection normally, we send a request, but we send it, I forgot to add it here, a keep alive header, which is part of the HTTP request, right? And then at the server, what we do is we will leave that connection. We're not going to close it. I'm going to keep it for you, sir. Right? As long as as long as we agree that both this connection are kept on both sides. So that's why the clients always is the person, all right, that tells the server, hey, please keep it alive. Please don't kill me. Right? And then we made another request. I don't need to create a new stupid connection, right? Fast stuff, guys, right? And then finally, when we're done, right, we close it. And whenever that means, right, when we're done, okay? HTTP 1.1 introduced caching with e-tags. I forgot to mention that. So 1.0 didn't have really good caching, this e-tags concept, which we talked about, right? So in the description, guys, there will be a bunch of links to my videos, right, to talk about all of that stuff, right? Hopefully YouTube will also suggest some of that stuff for you from my channel, which will be, if you go to watch it, you're gonna support me. Thank you so much, right? 1.1, we move to this persistent TCP connection or persistent connection model. If you heard this term before, that's what it means. We persist now. We gonna persist the connection, so we have lower latency. And then we have streaming with chuck transfer that we talked about instead of buffering. So the moment we have part of the HTML page, we're gonna send it, we're gonna send it through the connection. We're not gonna wait, right? Okay, so that's, and then so the moment we have, gonna persist the connection, so we have lower latency. And then we have streaming with chuck transfer that we talked about instead of buffering. So the moment we have part of the HTML page, we're gonna send it, we're gonna send it through the connection. We're not gonna wait, right? Okay, so that's, and then we're gonna tell the client that, hey, by the way, this is part 1, part 2, part 3, part 4. So at least if you want to show an image, you can show part of the image. I don't know if you guys remember back and when you had a slow dial-up connection, the image will literally just you can see the image loading. Okay, and that's because of the streaming chunk transfer. Okay, which by the way has been replaced with 2.0 with a better multiplexing functionality. But that's when you remember there's like the images. I'll try to put a GIF here or something. The image loading, showing you the image actually loading. Remember dial-up days? No, you don't? Okay, sorry. Pipelining. I don't want to. You can see the image loading. Okay, and that's because of the stream. Chunk transfer, okay, which by the way has been replaced with 2.0 with a better multiplexing functionality. But that's when you remember there's like the images. I'll try to put a GIF here or something. The image loading, showing you the image actually loading. Remember dial-up days? No, you don't? Okay, sorry. Pipelining. I don't want to talk about this because this is like some moot. It was a smart idea one, but it made more problems than good. Like this HTTP pipeline, it has been actually disabled by default in I think 2015 or 2017. So you know, HTTP pipelining is having this problem called head of line problem, where client keeps waiting for the packets to reorder themselves, and which is I'm gonna make another video just talking about that HOL problem. But pipelining, where we send these requests, right? And instead of sending and then waiting for the response, sending and waiting for response, sending and then waiting for response, the 3 blue lines will come first, and then the 3 red lines will come after. Okay, so we'll send them in parallel essentially. Okay, this could be multiple threads. This could be like the loop event, the loop mechanism, where we actually send them all at once and then wait for the result. The problem with that is the ordering, really. So we have really to guarantee the order, and that become really problematic. That's essentially pipelining in a nutshell, right? That's hopefully we're gonna close the video a little short here, right? I know I talked a lot, but I hope you guys really enjoyed this video. I know my videos are long in general, but I hope there are a lot of content for you that actually valuable, right? I don't make 2 or 3 or 4 or 5, even 7 minutes video. I think I couldn't. I'm not good enough to make that short a video delivering good content for you. That's why I need to talk about a lot of other things, because if I made a 7, 5, 6 minute video, then I'm gonna cut a lot of things, and to me that isn't a valuable video, because this channel is designed to make me a better software engineer, to make you a better software engineer. So you need to understand the details and nuts and bolts of things, right? That's why I need to talk about detailed things, okay? And that's okay. And if you disagree, I totally respect that, right? But that's why my videos are long. A lot of people complain about that. A lot of people, of you guys, love that I have made 20, 30 minutes videos, but that's essentially my points of this, right? So I make longer videos because there are a lot to talk about, okay? I can break them into multiple videos, but you have to jump through multiple hoops to get one answer, right? HTTP 2. I don't remember the timeline. I'm sorry, guys, for this, but it was designed to solve all problems in 1.1. Compression is one of them, but I really should put multiplexing as the first one. Multiplexing is essentially an idea where multiple requests come and get shoved into one channel. That's what multiplexing is. Like you go like a lot of wires coming into one place and you multiplex them into one. Okay, that's the same thing here. So if you remember our requests, think of timeline. I'm sorry, guys, for this, but this, right? So I make longer videos because there are a lot to talk about. Okay, I can break them into multiple videos, but you have to jump through multiple hoops to get one answer, right? HTTP 2. I don't remember the timeline. I'm sorry, guys, for this, but it was designed to solve all problems in 1.1. Compression is one of them, but I really should put multiplexing as the first one. Multiplexing is essentially an idea where multiple requests come and get shoved into one channel. That's what multiplexing is. Like you go like a lot of wires coming into one place and you multiplex them into one. Okay, that's the same thing here. So if you remember our requests, think of multiplexing like the client will join these requests and shove them into one TCP request, one TCP packet, if you will, not one TCP packet, multiple TCP packets as a one request. It goes as a one request. So logically, the HTTP protocol 2.0 will, which is called Speedy, by the way, and then it was renamed to HTTP 2. It was just shoved into one connection, and that's, you can see it just like doing that. We solved the head of line problem, which is like the ordering of thing, because I'm sending one request, right? It looks like 3 requests, but it's actually it looks like 1 request, but it's actually 3 requests or 4 or 5, right? So we start doing that stuff, multiplexing. And then we found a way to compress these things, because everything is now protocol buffers, which is that the open source format for was Google that designed it, instead of using JSON or anything. So it's using binary formats, not necessarily protocol buffer. You can't support that if you want to. It uses a server's push, so if you don't have to wait for the request to come, the actual server will push request, because it's a bidirectional, almost like a bidirectional request. Again, that looks like a request response to a fetch API to a browser, but internally it's a server push, which is slightly faster. Okay, I'm still thinking HTTP 2 is stateless, right? Although under the hood it is stateful. Because if think about it, all protocols are stateful because it's using TCP, which is stateful, but it gives you the impression that is stateless at the end. And I think HTTP 2 is still applicable to stateless, because if you destroy the server and you spin it up again, it doesn't hold information about that, or even it can resume my HTTP session quickly, right, without me even noticing that something has broken. Okay, that's the idea. It uses Speedy, and it's always those guys decided to secure by default, so it's always HTTPS. Okay, because of this protocol negotiation. And the protocol negotiation is because we have a lot of old servers now, 1.0 and 0.9, right? But we have to really negotiate, guys, the protocol that we're going to use with the server, right? So the client says, okay, can you support 2.0? Can you support HTTP 2, please? So this protocol is called Next Protocol Negotiation, and which has been replaced with the application layer protocol negotiation, which is a little bit better. This thing was trying to encrypt the requested protocol, which is kind of useless, right? Because but this one is like transparent on the clear, right? So I'm gonna make a video just about these two, essentially. All right, but essentially an idea is like you make a request and say, hey, this is the list of protocols that I support. Okay, the server picks one, and then that happens during the TLS negotiation. Okay, the TLS handshake, that's where these two things, which is just, let's talk about this because that's the new version, and that's an extension of TLS. ALPN is actually an extension of TLS that allows you to pick that, and it does it very quickly because it's part of TLS, and because it's part of TLS, it's always HTTPS, right? Right. And if it's not, then they have to do this other stuff to pick the protocol and all that stuff, right, guys? Finally, HTTP 2 over QUIC, okay, or recently, actually, I think 2018 September, it has been renamed to HTTP 3. It has been adopted by the Internet Task Force, Internet Engineering Task Force, IETF. Right, IETF. Okay, it's been renamed to HTTP 3 now. Okay, and the idea is it's exactly like HTTP 2, but it's instead of using TCP, which is slow because of all this frame ordering and the congestion control and a lot of other cons of the TCP protocol, the slow start and all that stuff. They decide to use UDP instead. They use that different. But the problem with UDP, just using UDP, it is lossy, right? You're gonna lose. You don't guarantee that you're gonna receive the request intact, right? Correctly, right? It doesn't have conjunction. It doesn't have anything. Just send the data, and you just hope that you're gonna receive it correctly, right? So Google came up with Quick, right? Which I think stands for Quick Use UDP Internet Connection, which people don't like to call it that. That's not an acronym for anything. It's just literally called Quick. Okay, and then UDP with congestion control. That's what it is essentially. And there's a lot of going on. I'm not gonna go through details, but it has all the HTTP features, but it replaces the TCP as this vehicle that transfers thing. And instead of this TCP, let's use Quick, which is the UDP with some features that makes it reliable, if you will. Okay, this is still experimental. It did not hit the road yet, right? Google is still, I think they're still using it though internally in Google server, but it didn't see a wide adoption yet, right? So it's still experimental. HTTP 3 is still experimental, but if you saw HTTP 3, that's it. It's just HTTP 2 over Quick. Okay, if I missed anything, guys, do let me know in the comment section below. Okay, obviously not perfect. Okay, this is my research. This is the research I did, and then that's what I found. Okay, we talked about HTTP anatomy. It's a long video. We talked about request response. We talked about 1.0. We talked about 1.1 over TCP, HTTP 2 over TCP, and all the problems that we solved, the speed that we got with each one of those, right? And then we're almost here, HTTP 2, and we're moving to HTTP 3 in the future. All right, guys, hope you enjoyed this video. If you enjoyed it, give it a like, subscribe to this channel, hit that notification bell to check out other content of this channel. We talk about all sorts of software engineering, right? That's the goal of the software, this channel, right? I want to become a better software engineer. I want you to join me. It's an unlimited game. We can never be the best because there is literally infinite information out there, okay? And it's like Pokemon. Thank you so much. If you really made it to this end, thank you so much for making it all this way, right? And a web server is a software that serves web content through the HTTP protocol. It is the foundation of the internet, and any website out there must be sitting and hosted by a web server. Web APIs like REST APIs can also be hosted on some sort of variation of a web server as well. Web servers can serve static and dynamic content. We're going to talk all about that. And you can use an out-of-the-box web servers like Tomcat or Apache or Lightly. Is that what it's called? I think it's called Lightly. Or you can build your own from scratch, like you build using a framework like Node.js or Express.js or Python Tornado, right? You can do all of that stuff with a web server. Okay, in this video, we will explain what is a web server, how it works, and we'll go through and spin off two types of web servers. One of those like ready-made web servers, which you can just install and just put static content on it and let it work. And we're gonna also explain how you can write almost your own web server from scratch using the web framework. We're gonna use Express.js for that, okay? But I've made a lot of videos about Python and web and Node, so check out the content in this channel, right? So speaking of which, if you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering. By example, we have tutorials, programming, we discuss software engineering concepts like what was a web server, was it a proxy, NAT, right? Anything that particularly interests me, I just add it as a thing to do in this channel, and in order for me to learn. If you're interested in that kind of things, hit that subscribe button and hit that bell icon so you can get notified whenever I upload a video. That's it. Let's just jump into this video, guys. All right, let's just jump into some, hopefully go through this theoretical part so we can show you some coolish stuff. And I'm going to add some jump codes here. You're going to see it here so you can just jump to your favorite part of this video. All right, we're going to talk about what is a web server in this agenda. We're going to talk about how web servers work, and we're going to show you the examples, right? This is our agenda for this video, okay? What is a web server? It is a software essentially that serves web content, period, okay? Define what web content is. Could be your HTML pages, could be just images, PDF, right? Anything that can live as a web and transferred as a web content is defined as web content. Okay, your API could be web content, right? Your JSON document is a web content. Okay, anything that's sent back text, right, can be web content. That's the definition of that. Okay, and it's consumed by clients who knows how to consume web content. Okay, let's talk more about that. That's why it uses the HTTP protocol. And guess what? We have made a video about the HTTP protocol. I'm gonna make it a reference here. So if you want deep dive into what HTTP exactly is with examples, go watch that video. I'm gonna reference it here. But essentially, it's the hypertext transfer protocol was designed, and there's different versions, different semantics, right? But we are now in HTTP 2. HTTP 3 is coming. HTTP 1.1 has been living for almost 20 years, and essentially this is what the web runs on. Okay, right? And that's when you say like HTTP // that's you're using HTTP protocol. Okay, if you want to learn more about it, go there. And all right, static versus dynamic content. So what does that mean? Okay, if you're like me, born a millennial, born in 1983 or a little bit earlier, a little bit after that, you would remember the early days of the web, where those flashy marquee text and the moving stuff, where the web was essentially just you consume stuff. Okay, you cannot really change anything in the web as a user. You can just consume. It's a static content. It's just a bunch of static content, HTML pages, right? Most of which were run on Apache, by the way. All right, so that's like the state of the art in the 90s, if you remember. Okay, so all these flashy images and essentially static content is like index.html, index pages, HTML pages, PDF, images, CSS, right? I don't know if the CSS existed in the 90s or not. JavaScript files also considered as a static files, which is funny because it's actually code, but it is nevertheless it's a static file. It's a file that you can download, and that's it. Okay, and here's the interesting part with that static files. So you can host a web server and you can put static files on them, and you can serve those very easily. We can show that. Okay, that's the cool part of the web app. So you author content, you paste it in a folder in your web server, and then your web server will immediately generate these nice URLs for you, so HTTP / whatever the folder you created, and then blah, you can host your pages, which is pretty cool, right? So people, instead of sending files by emails, you can just send people link URLs or URIs, okay, and then they will go to the content. So static files are cool because they can be cached, because no matter if they change, you can detect this change using e-tags and caching. Okay, and I'm going to reference this caching concept here if you want to learn more about it. Dynamic content, on the other hand, is when things like blog posts, right? It's a query to the database and will retrieve certain results. So based on the login user, you can get different content, different page. Facebook is an example of this, right? It's a dynamic. Nobody have the same web page ever. Okay, so caching this is a little bit tricky. Okay, so that dynamic content. Dynamic content is generated as a part of a language that you write code in the backend that generates different content, different page or web content based on a different context. Like could be the user, or it could be just the location. If you're coming from Asia, you're gonna get a certain like look and feel. If you're coming from America, you're gonna get different look and feel. So that's the dynamic content essentially. Okay. All right. Used to host web pages. We talked about that, right? So we can use to host web pages. You can use that's the 1.0 era, just web pages. You can use blogs and forums, right? Where you can. That's the web 2.0, right? Web 1.0 is just everything static. 2.0 is when things. It's all about APIs and how you can write Python on the backend. Little plug there. All right, so how web servers work, guys? How do this thing work? I'm gonna talk about concepts here that I explained before, so I'm gonna gloss over them, like TCP or TCP is, right? So if you want to learn more about TCP connections, check it out here. But essentially, what happens here is if a web server, this is a client, this is your web server, this is your client, could be a laptop, could be a mobile phone, and it's requesting a page. And what happens here is your IP address you have an IP address, that site will have a domain name, it could be having a host name, and then it is running on a port. Usually this port is 80. For web servers, okay, that's the default port. Right? If you don't see a port on the URL, that means it's port 80. But you can also run web server on any port you want. Okay, that's just the standard. 80 for HTTP, 443 for HTTPS. All right, so and when you have a web server running and 3 for HTTPS standard, 80 for HTTP, 443 for HTTPS. All right, so and when you have a web server running and listening on this port that there is a TCP socket or connection ready, right? And if you make a request, let's say get, that's the HTTP semantic we talked about, get me the index.html page on the example, right? And this is a syntax for HTTP. And when you do that, the server will process that request, perhaps maybe query the database. If it doesn't need to, just pull it from a cache or just pull from the directory and just serves you back the result. And then when you sends you the index.html or whatever that HTML page, and it also sends you a bunch of stuff in that response. We call this the headers and the status code, okay? And the status code is like, you might have seen the 200 okay or 404 not found, things like that, right? So the web servers have these HTTP codes that, and I want to make a series about all type of HTTP codes, hopefully, okay? That's the nutshell of that, but let's go dive deeper for those who are daring to dive deeper into this, okay? So another example of a web server, one example of this is what I call a blocking single-threaded web server. And I decided to explain that because it's the easiest to explain, okay? Obviously, none of the web servers work like that. And well, I take that back. So some web servers work like that, and there's benefits of that, but most web servers have different implementations. So let's talk about it. What exactly happened when I make that GET request, okay? So this is my web server. I just made it into a box so we can draw stuff in it, okay? And then when a client makes a request, whether this GET request, there is something happening before that, okay? The HTTP protocol runs on a transport layer called the TCP, Transmission Control Protocol, okay? So a transmission control protocol, what it does is it establishes a two-way communication between a server or a client, okay? But the HTTP protocol is just a request response. So if you make a request, the first thing it does is establish this TCP connection. So there's like some handshaking going on. If there's a TLS, you need to establish the TLS. If there's a secure thing. And then once you do that, the server creates in its memory, and very important here, memory. Let's focus on the word memory.
ভাও বলো কেমন আছো? কাল এক্সাম তো? क्या बात कर रहे हो भाव? ऐसा ना बोलो, आपका भी स्माइल बहुत अच्छा है.
Every client that connects reserves a little bit of a memory on the server.
TCP
Okay?
বাড়াচ্ছে না.
That's where
how
things
WebSockets work
can
with
get a little
server
tricky,
setup or
right?
Very
That's where all
basic
the
thing,
attacks, denial of
Basic-ই
attack,
পড়ছি যেমন কিছু
happens
high-type
because of this reservation of memory, okay? Reserve a lot of memory and your server crashes, okay? But, okay, your client connects, you reserve a little bit of a memory, and this thing is called TCP socket. You reserve a socket for that client, okay? Okay, and once you reserve a socket for that client, now you see, okay, we have one thread, one process with one thread that is allowed to execute stuff, okay? You can have 10 of those sockets, but they are sitting in memory. They are just idle, okay? But your process can only execute one at a time, okay? So I'm free. Your thread is free. Let's say there's a thread here that starts executing and says, okay, oh, you want me to get index.html? Okay, let me go do an IO desk or whatever, right? And then start getting busy. That thread means this sock is busy. It's doing something. That process is busy doing that. And that means that thread cannot do anything else while it's doing that, okay? So based on that request, that's a very simple request, but there are many requests that actually pulls from the database or does a processing, calculate, I don't know, prime number, right? Do your web API thingy. Okay, that's the tricky part where you need to do short circuit breaking, say a circuit break, and just break the circuit if the client executes for a long time. You execute that, you release, the thread is back, and it's back in normal. The client got a response, and we're good to go. So what happened now? Okay, so let's say the client makes another request. It can use the existing TCP connection. It doesn't have to create a brand new TCP connection, which is kind of fast. So having a TCP connection open with the server is a kind of nice thing. There's a bad thing about it is just you're reserving memory on the server. So if you have a TCP connection that is open and you're not using it, you're wasting server memory. Okay, but yeah, pros and cons of this, and we talked about the HTTP. And then we go execute and then release. All right, let's make this a little bit spicy. Let's add another client. Okay, one client makes a post request. That's the write request to the server. Okay, so I want to write something, like I want to create a new to-do list in my API, and the web server takes that and start processing. Then guess what? As a poor Joe Slop here want to connect to the web server, okay, and the server is a little bit busy, and now the web server implementations shine. What do you do? What do you do as a web server implementer? Apache does one thing, Tomcat does the same thing. All right, Node.js does another thing, Python does another thing. You can do whatever you want if you write your own as well. Okay, you can do whatever you want, but here's what a blocking single-threaded does. Okay, it creates that TCP socket for you, and that's it. It just does that. It creates a place of memory for you. But guess what? Sorry, I can't serve you. Yeah, the only thing I could do is just create that socket for you. Yeah, you have a TCP connection. Booyah. That's it. But I'm busy serving this guy now. Okay, that one thread is busy serving that. Okay, and then once you basically done, right, this guy can be served, and then you release and you're done. Okay, some of you might say now, okay, can you just spin up another thread? Sure, that's what Apache does. It spin up a new thread for every single request. Okay, and that's why you'll see when you go to Apache or Tomcat, there is a parameter called maximum thread numbers or maximum connections, right? How many of those do you want, right? I cannot just have unlimited, right? Well, you can change it to unlimited if you want, if you have unlimited memory here. But think about that when you really work with web servers. I like you to think about all of that stuff. It is really interesting to know how stuff works, especially web servers, because we work with these as software engineers. I mean, writing REST APIs, this is very critical to understand, guys. Okay, so your implementation of how it looks like is very critical. So you might be happy with a single threaded blocking, okay, but you might say, okay, I'm gonna spin multiple web servers like that. Okay, so I'm gonna put them behind a load balancer, and that's fine. Why not? Right? I don't see anything wrong with that. Might be some limitations, right? You can put in Docker containers. You can spin up as many containers you want off single threaded. I find this way more simple than having complex thread multi-threaded app web server, right? Let's have a discussion in the comment section, guys. What do you think is a better way of doing things, okay? There is no right answers or wrong answers here, okay? People still debating this, okay? Don't think this is set on stones, right? Don't just absorb information, discuss, right? Challenge everything that you read, okay? Nobody's perfect. Example. All right, example. I love this part. I love this part so much. Okay, so I did a Google search on some of the web servers, right? The one I knew was, to be honest, I knew HTTP. I didn't know it was called HTTPD. By the way, this is Apache. It is the other name for it is called HTTPD. I know IIS. I work with IIS most of my time. I work with Tomcat almost on a daily basis, my current job, right? I use HTTP server all the time when on my YouTube videos because it's the easiest thing ever in life. Okay, light HTTPD, which I think they force you to say lighty. I don't know why it's called lighty. There is an H, there is a G, there is a P, there is a D. As a foreign, like non-English speaker, this is all wrong by all means, you know. So write your own. That's another way of writing. So you can use an existing web server, or you can write your own. You can just use Node.js as a framework, a web framework, or you can use Python Tornado. So guys, you can write your own web server as well, right? And you can use Node.js for that. You can use Python Tornado, and that gives you the bare metal bones of things. It gives you how to listen to a port, gives you how to send statuses, it gives you how, hey, there is a request and a response came. Do your thing, okay? It gives you essentially a blocking single-threaded, okay, server, but you have to write all of that stuff for yourself, okay? These guys does most of the work for you. If you have IIS, you can just write an ASP application. I forgot what ASP stands for. ASP.NET Active Server Pages, I think it says that. I think something silly like that. So yeah, for Microsoft, you can just really enable IIS and just copy ASP.NET pages, and then works like that. For the demo part of this, guys, I'm going to show you how to spin up Apache 2, which is HTTPD also, okay? And we're going to show you, I'm going to show you how to spin that on my Raspberry Pi because I have Linux there, okay? That's the easiest thing. All right, and I'm going to show you how to do your own web server using Node.js Express. All right, guys, so here's what I want to do. I am logged in here to my Raspberry Pi, which has a Debian distribution, and I'm going to install Apache 2, which is HTTPD, which is the Apache web server, okay? And this is one of those ready-made web server where you can just throw a web content at it like HTML images, and you just will serve it for you. Very simple stuff, right? And so that's like the easiest way of hosting a web page or hosting a blog or things that if you want to host a web page or some like a company website, this is the easiest thing you can do, right? So let's learn how to do that, okay? So to do that, since I'm using Debian, I'm gonna do the apt-get here, sudo apt-get install. It's called Apache 2 for some reason, okay? Maybe the first version sucked, so they made another version. It's called Apache 2, okay? If you're using Docker, it's called HTTPD. Maybe we'll show you how to do that on Docker. So let's go ahead and install. It's gonna take a while. I'm gonna pause the video and show you back whenever this is done. I really can't believe that this is only 361 kilobyte, which is pretty amazing if you ask me, right? This is really, it's written in C, I think. So, or C++, I forgot. Last time I checked, it's written in C, so it's like very, very small footprint, right? Unlike Tomcat, Tomcat is written in Java, and it is really heavy stuff. But you can do way more stuff in Tomcat, obviously. But yeah, it's done. That's it. Okay, we just installed it. Well, in your case, I have installed it before, and then I installed a web page or some like a company website, which is the Apache web server, okay? And to do your own web server using Node.js Express. All right, guys, so here's what I want to do. I am logged in here to my Raspberry Pi, which has a Debian distribution, and I'm going to install Apache 2, which is HTTPD, which is the Apache web server, okay? And this is one of those ready-made web server where you can just throw a web content at it like HTML images, and you just will serve it for you. Very simple stuff, right? And so that's like the easiest way of hosting a web page or hosting a blog or things that if you want to host a web page or some like a company website, this is the easiest thing you can do, right? So let's learn how to do that, okay? So to do that, since I'm using Debian, I'm going to do the apt-get here, sudo apt-get install. It's called Apache 2 for some reason, okay? Maybe the first version sucked, so they made another version. It's called Apache 2, okay? If you're using Docker, it's called HTTPD. Maybe we'll show you how to do that in Docker. So let's go ahead and install. It's going to take a while. I'm going to pause the video, show you back whenever this is done. I really can't believe that this is only 361 kilobyte, which is pretty amazing if you ask me, right? This is really, it's written in C, I think. So, or C++, I forgot. Last time I checked, it's written in C, so it's like very, very small footprint, right? Unlike Tomcat, Tomcat is written in Java, and it is really heavy stuff. But you can do way more stuff in Tomcat, obviously. But yeah, it's done. That's it. Okay, we just installed it. Well, in your case, I've installed it before, and then I uninstalled it, so you might need to do it sudo apt-get update, and then sudo apt-get install Apache 2, and then you'll have it. So what do? Once you install it, you go to a folder called var www.root, and there's a folder called HTML, okay? And there's literally a page called index.html they give you for free to test your stuff. So let's go ahead and see if that works. All right, guys, so I am here on my Mac. My Mac and my Raspberry Pi are on the same Wi-Fi, so I can access that stuff, right? So I'm gonna go www.raspberry-pi.local, and by default, the Apache 2 listens on port 80. So this spins up the server on port 80 by default, okay? So if I do that and then runs, and you can see it works. And I'm using Debian, obviously. Okay, still tells you that you have your Debian distribution, but essentially it tells you what to do as well. Copy stuff in that, and you get yourself a web server that can serve anything you want. Okay, so since we guys are curious, let's do that. Okay, first of all, I'm not the owner of that thing for some reason, so what I want to do is I want to change the owner of this thing. All right, guys. So before we create our own HTML page and do fancy stuff, I want to own that HTML folder here because I'm not the owner of it. Okay, as Pi, the user. Okay, so what I want to do is go back a little bit, and then I want to do a sudo chown, which is change owner, and chown this thing from Pi on this folder. Okay, so that means the owner of this is moi. Okay, moi can now write stuff in it because previously I couldn't. So first thing I'm gonna do, first order of business, remove this file. Okay, and I'm gonna create one from scratch called index.html. Okay, and it's fancier. It's gonna be fancier. I'm going to do hello world. This is my page hosted on HTTPD or Apache 2 because the first version sucked. Okay, body. Did we close that? Yes, we close this, and then we do dit, and then that's it. We just created an index.html. Let's go back to my Mac. All right, we are in my Mac. I am about to hit refresh. Hopefully, my server is smart enough to not cache that page. And guess what? It worked. It worked. All right. And you can pretty much put any stuff there, and it will just get hosted for you. Okay. And let's say, for example, I don't know. Let's do a main.js file here, and that does literally an alert. Hello world, I'm JS. Okay, and then we can edit my index.html, and then we can do fancy stuff like that here in the body, saying script source equal, what did they call it? Main.js. Since it's in the same folder, we can get away with that. So let's do that. And then when we refresh, we're gonna get an alert because my JavaScript got executed. So what happened here, if you literally took a look of that, right? When you refresh, two requests made, right? The first request is to get the index.html. This is the 200 OK. Obviously, we talked about that. We got back an index.html. It's a text, right? And that thing, when parsed by the browser, discovered that there is another thing it needs to pull. So that's back to our TCP connection thing, guys. So if in HTTP 1.0, these two was two TCP connections, which is extremely slow because every request will start a TCP connection and close it at the same time. Now there's something called keep alive. I'm alive. Oh my god, this video is gonna get demonetized. All right, keep alive, right? So it's gonna keep it alive, keep the connection alive, baby. That's what it. Yeah, keep the spark alive. So once it keep the connection alive, the second request, okay, will actually make that request to get that main.js. Okay, obviously when you write your own server, you have to do all of that manually. You have to do the caching manually. You have to do all that stuff. But this guy, the Apache, does caching for you, okay? And let's prove it. So 304 not modified, that's the E tag. Okay, guys, I'm gonna reference the E tag here. Go check it out. What is the concept of that? But in a nutshell, this is the caching mechanism. So what the first time, let's disable caching and let's show you that. The first time I make a request, okay, to any content, I get back an E tag, okay, and the client then use that E tag with every single request it makes, okay. So if I make a request now, and the client sends that request, says, hey, if not match, tell me, did this E tag change? Tell me. If it didn't change, coolish, okay. But in this case, the JavaScript didn't change, so it says, nah, you're good. Whatever you have is good, okay. So let's see how good the Apache implementation is. So I'm gonna go ahead and do main.js, and I'm gonna edit that thing to say alert, hello world, I am JS, and I just changed, baby. Okay, and sure, let's do, I don't know, another alert message, because that's the only JavaScript code I know. I'm kidding, guys, I'm kidding. Oh my god. All right, that's another JS, right? And let's see if the implementation of the thingy is smart. So I'm gonna go ahead and, what was our original? I lost it. Dash. Okay, no problem. It was a certain E tag. The client will attempt to send the same E tag, but what? Look at that. We got the new stuff. That's another JS, right? So what happened here is we sent it the same E tag, but we thought, nope. We got a new A tag, okay? I don't know what gzip is. We're zipping this thing? That's what. It's just like the implementation of the actual web server here, okay? So the web server says, nope, it has been modified. All right, so that's essentially the trick, guys. That's that simple stuff. Let's show you how Node.js works. How about that? Right? So we're gonna write our own implementation here. So in order to write our own implementation, we need some decent editor. We cannot use Vim. I mean, we can, but yeah. It's just a lot of work. Okay, all right, so I have Visual Studio Code here. I have Node.js installed. Go ahead and check it out. I'm going to reference a video that we have installed with Node.js and all that stuff. What I want to do essentially is just create a brand new folder with Visual Studio Code. Let's call this web server from scratch, okay? And then just a brand new folder. There's nothing in it, okay? And you go here, and you click on this guy, and you will create a new folder, file. And that file, because I'm writing JavaScript on the back end, you have to write your own code here to do everything, okay? To serve web content here. So I'm going to say index.js, and I'm going to create our index.html page here. And since we are an editor, we can actually write the entire HTML with just one click instead of having to write everything. Hey, H1, hey, I wrote all of this myself. Node.js, babes. Okay, so that's HTML that we want to serve, but we need to listen to a port. We need to receive requests, we need to send requests, we need to do all of that stuff. So let's get into it, guys. So, and you pick then at the end of the video, you pick what is the favorite part for you, okay? So I'm gonna do an app here, const app equal require express, okay? And that's just the bundle. So we need the app, we spin up a version of that, okay? Like literally a function call or constructor or tor, ctor. I don't know why everything is an abbreviation with people. Okay, constructor, can't you say constructor? Really, you have to type tor? Oh, I know, man. API people, guys, I'm telling you. App dot, here's what I'm gonna do. App.listen. You're gonna listen to port 8080 because 80 is kind of reserved for highly privileged apps, and I'm not one of them, so I can't listen to them. I have to run as a root, and I don't want to. So let's just listen 8080. And when you're done, you say console.log, sup, I'm listening. Yes, sir. What do you want? Okay. This is just for, what the heck is happening? Okay, this is just for us to know that we're listening correctly. But that's not enough. Okay. Well, let's run it so I can show you. Okay. I have Express installed globally, so that will work, right? But that's it. Sup, I'm listening. Yes, sir. What do you want? Okay, that's it. Okay, but that's not enough, right? We need to really accept the request. That's, if I do that now, let's see. If I do that, and let's say run, and let's just say localhost, right? See that error I'm getting? So now, guys, if I go and try to go to localhost, which is my machine, 8080, I'm getting this error. Cannot get. Why? Because you didn't implement anything, right? There's nothing there, okay? If you refresh there, look at all these errors. Forget about those. But look at that, 404. Because that's the only thing that the application that says, hey, there's nothing on that server. The server is dead. Okay. So here's what we need to implement. We need to implement a get method, a get slash method on the root. Okay. So that's the first thing we need to implement. Remember, we didn't have to do any of that. Okay. We have an index.html. It didn't get served. We have to tell it to get served. How? We can do app.get on the slash, if someone visited me on the slash on the root, I want you to call this function. And this function always has to take two parameters, request and response. Okay. And then what you do essentially for simplicity is you don't really care about the request. Sometimes you do, obviously, but here we don't. There's nothing in the request. I just want, if someone visited me, I just want to send file, and then you send it the index.html file. Okay. And to do that, we have to do all that stuff where it's in my directory. This is to avoid hackers pulling all your stuff. So you have to specify, you cannot use relative files here. So you have to do that. Okay. So that will take the directory name and then index.html. Okay. So that will serve the index.html page. Okay. Let's try that. Restart. And now if I refresh, hey, I wrote all of this myself. Node.js babes. Okay. You like this, babes? You like it? This is the best, right? This is the best. And if you served another file, you have to do the same thing again. Okay. Anything. Okay. There's obviously regular expressions that you have, like any, if someone visited anything, then serve them anything. A little bit dangerous, but you have to do, know what you're doing. But that's essentially how you write web content. Can you do something else? Sure, sir. You can do get slash sup, anything you want, really. And then request response. You can do, we have the function here. We can, for example, did we get back from the headers? We get back 304 not modified, and we got back the results. Okay. And now, can I change that? Yeah, sure you can. You can do results.status code, and instead of 304, you can change it to anything. 404. What is a 404? You guys know, right? 404 is not found. Although it was found, but you can tell it whatever you want. That's the flexibility you get when you write your own web server. Okay. Although the document is there, you can have a statement. Hey, if this exists, do that. If this, do that. You can add all of kind of stuff like 201 code, which is, I forgot what it is. I think accepted or something like that. And create it, right? You can do anything you want. All this stuff. If you change this to 418, for instance, right? This is one of the April Fool's status codes that have been created. Look what you get. I'm a teapot. I don't know what the heck is that. You can actually change it to whatever you want. Okay, did what 401 hit? I am a teapot. That's one of the status codes that is being documented, and it's going to be there forever. All right, guys, that is our video today. Hope you enjoyed it. Give it a like if you do, and if you learned something, subscribe to learn more, and share this with your friends. And I'm going to see you in the next one. You guys stay awesome.
WebSocket technology is a bidirectional full duplex protocol for communication between the client and server over the web. It has been standardized in 2011 and it's fully compatible with HTTP. This protocol enables real-time applications such as chatting, notifications, live feed, multiplayer gaming, and other use cases as well. In this video, we will explain what WebSockets are, why it was invented, and we will build actually an example with WebSockets, a client and server using WebSocket. I'm going to use Node.js for that. And we will also talk about the pros and cons of WebSockets because, let's be honest, guys, there's no technology that is perfect. Everything has a pros and cons, right? If you're new here, welcome. My name is Hussein, and in this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing, hit that bell icon so you get notified whenever I hit a new video. With that said, let's just jump into this video, guys. WebSocket, here's the agenda. Here's what we're going to discuss. Before we jump into any technology, I like to go back and say, why did we invent this thing, okay? And that brings us back to HTTP, okay? I need to talk about HTTP a little bit, okay? We're going to talk about HTTP. What is it, okay? Not in detail, just a little bit, okay? Because this will allow us to jump into why we have WebSockets. Then we're going to discuss this concept of a WebSockets handshake. Then we're going to discuss a little bit of use case of WebSocket. We're going to talk about an example, some code, yay! We're going to show some code. And we're going to show you like the pros and cons of this technology. We're going to talk about these pros and cons of this technology. And you guys are going to see the jump codes here under the screen where you can just go to that for minutes, seconds to watch any of these topics that you're interested in. You don't have to watch the whole thing. So it's really up to you. Okay, guys, what do we have? We're going to talk about, first of all, HTTP 1.0. And he was like, why? Why are we talking about technology from 1995? Very good point. Okay. There's a lot of, while researching this video, I was watching a lot of videos, and there's a lot of misconception and wrong information. Okay. So I just wanted to literally just clarify some of the things. HTTP 1.0, which is the first technology that was invented. And here's how it works. Okay. HTTP protocols, obviously, guys, it's built on the TCP protocol. And we made another video about HTTP. I'm going to reference if you want to learn more about it. But in a nutshell, it's built on the TCP protocol. When we first invented this HTTP, first version, we said it's going to be a request response. And close connection for every single thing. Okay. There's like you send a request because you don't really have the server and client guide. They both server. There are use cases that the server needs to send me information despite me not requesting it. Okay, as a client. Okay, and that's why we invented other technologies other before WebSockets. But WebSockets became the dominant one here. Okay, let's talk about WebSockets now. So what WebSockets does is it's essentially uses the HTTP 1.1, this persistent TCP connection, as a vehicle to send data from the client to server and the server and client guide. They both aware of each other. That means it's no longer stateless, it's a stateful, right? Because the server is aware of the client is aware of the server. The moment this awareness happens, it's a stateful, okay? It's a stateful thing. HTTP, on the other hand, it's stateless because you don't really have this awareness. You can kill the server, restart, and the next request would just be served normally. So how does WebSockets work? The first thing happens, we do the same thing, right? We about to send a HTTP request. We do the WebSocket handshake, which involves a little bit of information that we're going to talk about. It's still an HTTP request, okay? An upgrade request with some salt and pepper there. But what will happen here, this handshake will first happen between the server. The client would say, hey, I would like to do a WebSocket connection if you would mind. Okay. The server would say, hey, I don't support it, or hey, I support it. Cool, let's do that. And then what will happen is there's no order. It's a binary protocol. This WebSocket becomes a binary protocol. It's detached from HTTP, okay? And then it's the Wild West. Anyone can send data to anyone. The server sends client the data because both know of each other now. They have the API access to the underlying TCP connection, okay, with a little bit beautiful API. It's not as ugly as TCP with segments, right? So the server sends information to the client sends information to the server, client sends another stuff to the server sends back something, client sends that. There's no order, okay? And the server sends twice, and client and server sends information concurrently. Who cares? That's what WebSockets, okay? And based on that interactivity, a lot of use cases were born, okay? So let's talk about a little bit more about the handshake itself. And when we talk about the handshake, and the first thing we need to talk about is this protocol, which is WS, which stands for WebSockets, okay? And if you do what WebSockets on TLS, then it becomes WebSocket secure, okay? We talked about TLS. I'm gonna reference it here. Go watch that video. But here's what we do, guys. Here's what makes WebSockets really awesome. The first request that we make is an HTTP normal GET request, right? That means when we make that request, it's an HTTP 1.1. So I mean, I'm gonna establish the persistent connection that we talked about. But here's the really awesome. The first request that we make is an HTTP normal GET request, right? That means when we make that request, it's an HTTP 1.1. So I mean, I'm gonna establish the persistent connection that we talked about. But here's the special thing. There is an upgrade header in that request, and that's really powerful stuff, okay? So it's really a GET request, a simple request. The server takes that because it's a web server. We talked about web server. I'm gonna reference it here. We talked about a lot of stuff in this channel, right? And it's a web server, so it consumes that. But here's what if the server knows that the client is trying to upgrade this 1.1 connection to something else, to WebSocket in this case, the server will reply either cool, I'm switching the protocol, and the status code is 101. You know, the status code, guys, 404, 200, 201. This is a special status code, says 101, switching protocol, you cool. And once we switch the protocol, then we start communicating with this binary protocol. So that's the handshake essentially. And it has to work on 1.1 because of this persistence that we talked about, guys, right? It will never work with 1.0, okay? And recently, I think also WebSockets work with HTTP too, because it's the same concept, right? It's still persistent connection. And we close the connection. And here's how the actual handshake looks like, right? I took this from Wikipedia, okay? And then you do a GET request on, for example, any endpoint. It doesn't have to be chat. You can name it literally anything you want. It has to be HTTP 1.1. And you say, hey, I'm this host. You can block this host if you don't want to. And you want to upgrade this to WebSocket. You want to upgrade connection upgrade. That's the special hit. And there's these keys, right? And using these keys, the server will take them, does some seeding and hashing, and then send back a new WebSocket accept, okay? So that you take the value and the client will verify that it's actually that server is the one who sent me that value, okay? This is just for the server receive information from the actual client. We get that WebSocket, and that's it, okay? So we receive 101 switching protocol, and we're good. So that's, you can build your own WebSocket server that does know how to deal with that, but you can always use an existing library that does that for you, because it's a little tricky to do the binary protocol, right? And use cases. Why do I need this duplex, full duplex, or whatever you called it, Hussein? Why do we need that? Chatting, right? You know, chatting is not something great for request response. It's not, you're not loading a page. The client can receive a message like WhatsApp, right? Someone can send you a message without you requesting it, right? You don't want to say, hey, is there a message for me? Is there a message for me? Is there a message for me? You don't want to ask for that, right? You want the message to get quote unquote pushed for you when there's a message, right? So chatting is a perfect example for this, right? And having the client request something only to find out that there's no chat for you is just not working, okay? And live feed. Hey, I want to connect to this feed, and whenever there's a blog post, just let me know, okay? Or any notification, Facebook notification, all right? I'm not saying that Facebook uses WebSockets for this, but I'm saying that's one way of doing it. I think Google Wave, when it first launches, I do remember them using WebSockets, and it was really amazing back in 2011, right? And I still remember that video, and I was watching that video, and they were just typing, and the immediate window, you can see that, oh, person one is typing a message, and that was really mind-blowing, because I know that HTTP couldn't do that, obviously, right? So it was a little awesome to read about that. Multiplayer gaming, obviously you can build gaming. Multiplayer gaming is like, hey, multiple players, they send input, and the second client can receive information, right? So here's a little bit tricky. Okay, when you have multiple clients connecting to one WebSocket server, this WebSocket server have to maintain multiple connections, multiple TCP connections with each of those guys, okay? And that makes it also more stateful. And statefulness means what, guys? We talked about this. You cannot easily horizontally scale stateful application, because when you destroy the server, all those guys just dead, right? You can obviously write it in a stateful way, but it requires, it's not natural, right? You have to write more code to make it stateless in order for it to horizontally scale. Doesn't mean that it cannot horizontally scale, okay? Show client progress logging. You know, when you upload a file, you want the server to send you updates that, hey, the file has been 70% uploaded, 80% uploaded. Or you're rendering a video. You're like, make this MP4 into a GIF or GIF, wherever party you are, okay? So if you upload that video, you want the client server to send you information about that, okay? So yeah, you can use WebSockets for that. You don't have to though. I want you to keep that in mind. WebSocket is not the solution for everything, okay? Don't get attached to anything, guys. Don't get attached to that technology. Code time! WebSocket example. Here's what I want to do, guys, okay? I want to show you an example of a raw WebSocket client server, okay? And to do that, I'm going to do it in very bare bone. A lot of people make the mistake of, when they want to learn WebSocket, they go download some sample that has like a chatting application. And that's like, to me, at least, it was like the worst way to learn, okay? Because chatting application is not easy to implement with WebSockets, because you have to have multiple array of connections and all that stuff too. It's not easy to understand. So in my opinion, I'd like to show you how this server talks to client talks to server with very basic stuff. So we're gonna write the server, and the client will be, guess what? It will be the browser from the console window, because we can write JavaScript code there. And it's beautiful, guys, how powerful JavaScript is, because this WebSocket client is available literally on your browser. So I'm not gonna allow you to, I'm not gonna let you forces you to write HTML code and script tags and all that stuff, right? So we try to write as less code as possible. Let's just jump into it. All right, guys, so I have Visual Studio Code here because it's the best editor ever. You can argue with that if you want to, but Visual Studio Code, I really like it because it's very lightweight and supports a lot of scripting languages, Python, JavaScript, TypeScript, name it, right? So I like it. And we're gonna build our own WebSocket server, okay, using Visual Studio Code, using Node.js. Okay, so we're gonna build that. So you have to install, you have to have Node.js installed, obviously, on this machine in order to build that. Okay, so let's start with that. We're gonna start from scratch. I'm gonna obviously go to Open. I'm gonna create a brand new folder here on my JavaScript folder here. I'm gonna create, let's call it WebSocket Demo. Okay, and then just like that, Open. And then here's what I want to do. I want to create a new file called index.js. Okay, so this is Node.js, right? And then what else do we need? Let's initialize this project with npm. So go to terminal, and then literally we don't really care. Just do npm init -y. That means, hey, initialize this project with whatever. And this will create us the package.json. We don't really care about that. This is just for us to debug, okay? And then here's what we want to do, guys. Okay, let's zoom in so you can see. We will create the HTTP server here. And this is using the HTTP library here. And that will have the persisted web server that we talked about, okay? So that's the web server that we're going to create. We're going to create a server using this native thing, okay, which is the HTTP server. We're going to spin up a little bit of a mini web server, and then take that server, inject it into another library that will allow us to do that handshake we talked about. So let's do that, guys. So HTTP, and here's what we do, right? Const, I'm going to create HTTP server equal HTTP.create server, and that essentially takes a request and response function, and then I am going to just literally just log it here. We have received a request, and we will add a breakpoint here because here is the first
Nothing really. I do this because I love this. No motivation, no nothing, man.
call of the request will come here, because specifically if you create a new WebSocket, the first call is what, guys? The get upgrade, remember? So I want to show you that get upgrade here. And when we have a server, we can just listen. And let's use a port that I never used before. I think 8080 is free. Okay. And then let's just say console.log. My server is listening on port 8080. Don't make fun of me. Okay. Listening. It's funny because that's when I first learned English, I used to literally read this listening, and it was funny. Okay. Yeah, you're laughing, guys. Okay. So that's the first thing we need to do, right? Let's just run it, make sure it works. Okay. Obviously, there's nothing. Hey, okay, my server is listening. That's not a WebSocket though, right, guys? That's not a WebSocket. Let's make a WebSocket, and here's how we do it. Okay. We're going to do WebSocket. Let's make it capitals because it's a class. WebSocket server equal require WebSocket.server. Okay. And that will give us the class, which will have this beautiful events, like say, hey, if you received a message, do this. If you received a connection, do this. If you do this, and all that events, which makes it stateful, obviously, guys, right? So we have a WebSocket server. Here's what you do next. We're gonna create a WebSocket, if I can spell it right. WebSocket server, and here's what it takes. It takes a JSON, and that JSON is HTTP server, and you pass it the HTTP server you just created. It needs that. It's just, remember, guys, this is just the handshake part and the messaging, right? We're gonna use that protocol to actually authenticate, right? Do the handshake. So we need to send it the HTTP server that we just used, which underneath it has a socket which has the TCP connection. So we send it that. We're gonna create a WebSocket, if I can spell it right, WebSocket server, and here's what it takes. It takes a JSON, and that JSON is HTTP server, and you pass it the HTTP server you just created. It needs that. It's just, remember, guys, this is just the handshake part and the messaging, right? We're gonna use that protocol to actually authenticate, right? Do the handshake. So we need to send it the HTTP server that we just used, which underneath it has a socket which has the TCP connection. So we send it that thing. Sweet. What else? What should I do next? Next, what you do is you have to have an event here on request. If someone requests this WebSocket, right, go ahead and call this function. Here's what happens here, guys. So the first thing we do, we make this GET request, right? And that GET request have the upgrade. It comes here, and then you decide as a server whether you want to accept this WebSocket request from the client or not. And guess what, guys? I'm going to accept it. I am going to accept it because I accept everything. And then this parameter is interesting. You can create your own like fancy protocols. Like if your server supports like gaming, you built like a gaming protocol, you built like a chatting protocol. You can accept whatever the client sends you. You cannot just accept any WebSockets that won't be secure, right? So you can accept the things that the client will support. Okay, and we're gonna accept anything because it's just an example here. So null. Okay, and then the origin here, which is request.origin. Do you want to, you can check the origin. If that origin is not trusted or you don't like it, you can just say, nah, I don't want to accept that. And here's the interesting part, guys. We're gonna get a connection of this, connection. Okay, I know people make fun of my accents, like connections. I don't know how to say connection. Okay. Okay. So connection, we're gonna get a connection. I'm gonna make this as a quote unquote global variable, whatever, right? So let connection equal null. And I use let here because I'm gonna override it. I cannot use const because I'm gonna override this literally. So I'm gonna do connection equal that. And then here's the thing. If you do connection, you can add other stuff on open. If the connection has been opened, call this function, right? Console.log opened. Zoom out a little bit. I think you can read it this way, guys, right? And then if the connection is closed, do this, closed, right? And you can do some other stuff here, maybe notify the database to do something, right? So you can write any function you want here. You know, we don't really need to do a variable here, right? And here's the most important function of them all. It's called onMessage. If you receive a message, get me the message. And here's what I want to do with this message. What are we going to do with the message? Right? I'm not fancy. This message will just literally print it, right? I'm going to print whatever I receive from the client. And it has to be an event, guys, right? So received message, and then we can say message dot, I think it's called UTF data, something like that. All right, we'll find out. Okay, I don't remember what the property is, but we're gonna find out, guys. Don't worry about it. Do not worry about it. Okay, and then obviously that's it. I think that's it. We receive a request, open, close, message, and that's it, right? And here's let's run. We got an error. Cannot find module WebSocket. Well, what do we do, guys? Simple. npm install WebSocket in the same folder, so we can install this technology. Install this module for me. Okay, that's one of the modules, guys. There's Socket.io. There's other stuff, but that's what I saw. That it's like the simplest one, really. It's big though. I don't know why. Okay. Can you build your own? Of course, you can go ahead and try that. Download the RFC and then write your own. But it's up to you if you want to write your own. Okay, but okay, let's try it. I'm gonna listen to 8080, and we're listening. Okay, our WebSocket server is ready, guys. Okay, let's go through the code a little bit quick before we jump into the client and write that. So we have the HTTP server, which is like the raw server. Okay, we have the WebSocket server, which allows to do this the handshake, right? Because it's exactly this thing, right? On request, when I do accept, that will send back the switching protocol that we talked about, and we get a connection as a result. And that connection, we're gonna do beautiful stuff with it. And that connection, we're gonna take that connection. There is a method called send, and we can use it to send information from the server to the client. Remember, guys, I am in the server here. This is the server code. Okay, let's go to the client. I'm gonna create a new page here and literally go here and then more tools, developer tools, or in Firefox, you can, I think, called Web Console or something like that. And here's the beauty of this thing, guys. Since it's JavaScript, since WebSocket comes with every single browser, you can write this WebSocket client right there, okay? And I'm not gonna bother writing HTML code. Let's do that, okay? So I'm gonna do let ws equal new WebSocket. Guess what? That's what you do. What's the protocol? WS, right? Because this is a WebSocket. What's the IP? What's the host name? It's localhost. It's on the same machine. What's the IP address? 8080, right? I was like, this is the thing we're running on. It's running on 8080. And then when we do that, let's make sure we have all the breakpoints so we don't miss anything. So here what I'm gonna do. Hit enter. The first thing we get, what? We got a request, guys. We can use that request to guess what? Get the origin. We have the Chrome search, wherever the origin is that. And then when I do that, I accept the connection. I just got the connection now, right? And then we set the events, obviously just wire the events, and guess what? We received it. Here's what I want to do now, guys. I'm not gonna stop debugging. I'm gonna go back to the client, and here's what I want to do. When I do WS, I want to wire the events on the client, which I did not do. On message, if someone sent me a message, I want to take that message and then, guess what? I want to print it. I want to print that message. We received a message from server, and the message is, let's have, by the way, how do you do what is called the text, which is like inline formatting. So I just want to print the message.data. I think that's how you do it, okay? And if we do that, nothing will happen. We just wire the event. So when someone from the server sends the client a message, we should get something printed here. How about we test, guys? I'm gonna go to the server here, and in the debug, I have access to the connection, right, guys? I'm gonna do connection.send. What? Hello, client. It's me, Asar. And then hit enter. Let's go back. What? Look at that. We received a message from the server. Hello, client. It's me, Asaf. How about that, guys? Should we do the other thing? Let's do it, guys. Let's continue that. Go back to the client and then say ws dot. How do you do that? Send. Hello, server. It's me, client, baby. All right. And then let's make sure we have the breakpoint. We do have a breakpoint. So this function should be called because on message, right? On message is the function that will be called when the server received a message. Let's receive a message and send. We sent a message and we didn't get it. What's going on? So apparently I typed the wrong event name. It's not called on message or on open or on close. It's just message close open, right? Let's restart and let's try again. Since we are restarting, guys, obviously that just proves my point that this thing is stateful. Look at that. There's a word state there. Okay, so it's just dead. So how do we do this again? It's okay. Just connect again. Let's just do it again. All right. So let's establish the connection once again. Okay. Let's just do ws. Whoop. We go come here. We forgot we removed the connection. Then that, just like that, we have a connection now. Let's do the message. And then we have the log here. Let's go ahead and ws.send. Hello, server. It's me, client, baby. This time it should work. What? Look at that. It immediately, boom, boom. All right, got it. And now, here's what I didn't know is like, what is this called, right? So message is essentially a JSON object, and there is something called .utf8 data. Okay, so that's what we sent, UTF-8 data. So we can do .utf 8 data. Okay, so now if I do this, it should just print it. Okay, let's restart it one more time. One more time. Right, one more time, guys. We're gonna get it. All right. Ooh, request. Accept that request. Let's do this again. Wire the message on the client, and then how about we clear this and then send, and we get it, we print it, and there you go. We have the message here. Received message from the client. It's me, client baby. All right, guys. So here's what I want to do now. Okay, you can take this and run with it, right? The trick here is the connection. If you want to build a chatting application, you have to build an array of connection. And every time a client comes, you add it to this array. You push this connection to an array. And then you start maintaining these states of connections, pool of connections. And then every time someone sends a message, you can send the group message back to all the connections, okay? So we can build something like that. I'd rather build it in another video, and we focus on just the raw WebSockets here. I want you to understand that it's a connection. You can send information from both states. Okay, and let's build one more function here. I want to build this. I want to configure the server to send a message to the client every 5 seconds, like a random number. So how do I do that? Okay, so I want to build a function like stop this function, function send every 5 seconds. Okay, and then here's what I want to do. I want to literally do connection.send and then message. I'm gonna send a message and then math.random, literally any random number. I just want to send a message to the client. Okay, I don't know, this could be logging, this could be anything you want, right? So we're sending the connection to the server, the client messages, right, all the time after every second. How do we do that? Set timeout. Okay, and literally just call yourself every 5,000 milliseconds, and that's it. But this function is never called. So after a connection is accepted, go ahead and call this function, which will always send a message to the client. Let's do this again, guys. So guys, can we build an application that have like a decent client? Our client is lame, but you get the idea, right? You can build a script that actually does exactly what we're writing. I don't want to write a lot of code. I try to minimize the number of code that we write. Okay, obviously this thing is broken now, right? The ready state is 3. We need to establish a brand new shiny object. Go ahead and write that. And now the client, by the way, the server started sending us messages, but we cannot receive them. You know why, guys? Because we didn't wire the onMessage event here. That's what confused me. On messages on the client, right? On the server, it's not called onMessage, it's just called message, okay? Yep, let's do this. Now, yep, we got a message. We received a message from server, message function random. Yikes, I know what's going on here, guys. We're sending the entire function, Jason. All right, let's fix this. Yeah, I forgot to invoke the function. You know the difference, guys, right? I am sending literally the stringified JSON of the function, right? I didn't invoke the random function to give me a random number. I literally just sent off the function, which was dumb. Okay, guys, let's do this again. By the way, guys, I'm gonna make the code available, so don't worry about having to pause the video, right? But yeah, we received the message. Accept that. Let's go ahead and accept it. Wire the message, and there you go. 1, 2, 3, 4, 5. 5. There you go. 1, 2, 3, and 4, and 5. All right, guys. Okay, you got the idea, guys. So can we send something to the server while we're doing that? Sure. Hello, babes. You get. Oh, if only I can write. If only I can write. Yeah. Sure, we can receive message. Just remove these breakpoints, and you can see that babes receive a message. We send another babe message. We can get it here, right? We get the messages, and it's a two-way communication between client and server. So now, guys, if you want to build like multiple clients, one server, you can always do that, right? Okay. Our server currently does not support multiple clients. If you do, it will accept it, but it's going to be very bad because we're having just one variable, one object maintaining the connection, and whoever last wins essentially, and you're going to leak stuff, and it's really bad. Yeah. If you close the connection, obviously, let's try that. Close the connection. Is that how you do it? Close. And if you close, essentially, closed. And you know what happened here, right? We called this function essentially. Okay. Sweet, guys. Let's go back and talk about pros and cons. All right, guys, we learned about WebSockets. We saw an example. Now, we need to learn about this pros and cons of this technology because there's nothing perfect. There's always pros and cons. Okay. So what's bad about this? What's good about this? What's good about this? Pros. It's full duplex. So if you are building an application that requires the server to send you updates, okay, you do not need to do polling essentially, and you do not need to ask the server, hey server, do you have this? Do you have this? Do you have this? Do you have this? Are we there yet? Are we there yet? You don't have to do that, and that's you have to do that with HTTP with HTTP because it's a request response system, right? Full duplex, on the other hand, you don't have to. Server can send you information, client can send you information, right? And you can build it for gaming, and you can build really cool apps with this technology. It's HTTP compatible because of the upgrade header. Without that, proxies will fail, things can go bad. Nobody can know this is actually a WebSocket, right? If you started just creating a socket, right, and then sending binary information, the firewall will start blocking because it's like, what the heck is this, right? What are you sending me, right? But because it started with an upgrade, with a legit HTTP request, and then we upgraded it to a WebSocket, that kind of passes all the internet infrastructure, and it will should work with anything, right? There are problems there, but we're going to talk about them. It's firewall friendly because it's a standard. It's HTTP. It's only 443 or 80. Well, you can listen on any other port, and that's how HTTP works, right? HTTP web server, you can listen to any port you want, but usually it's just 40 if it's just 40. Usually it's 80 when it's insecure. It's 443 when it's secure, okay? And what else? Oh, we're already out of good things. I can probably think of more good things. I just didn't add it. Cons! Proxying is very tricky, guys. Nginx just recently started adding this to its WebSocket support, right? It's real tricky to know that, hey, you're receiving a WebSocket request and you have to do like HTTP upgrade, and the server has to respond to the HTTP upgrade, especially if the proxy is a layer 7 proxy. Because, we talked about layer 7 and layer 4 load balancing and proxying, guys. I'm going to reference the video here. And what happens essentially with layer 7 is proxy has to break the TLS, right? It has to terminate the TLS most of the time in order to look at the layer 7 data, which is HTTP. And the moment it does that, it has to create its own TCP connection with the destination server. And God knows how you can handle this WebSocket, and because there will be a bidirectional between the proxy and the server, and then another bidirectional between the client and the proxy is just a mess, right? Okay, so I really recommend just doing a layer 4 load balancer or proxying and just never worrying about it. Okay, yeah, layer 7 load balancing is very challenging. Dealing with timeouts, because proxy HTTP normally have a timeout, right? Server timeout, okay, but WebSockets shouldn't have timeouts because you're using the connection. Yes, of course it's gonna take a long time. It's gonna stay open for a long time. Even if it's not used, you shouldn't terminate that for me because I can use it at any second, right? So timeouts is tricky, right? And you probably don't care about these things, but it's good to mention. It's a stateful protocol, right? We saw this variable called connection. It is literally on my server. So if I restart my server, my connection is dead, the client is dead, and you just lost the connection essentially, right? You have to reestablish that. Okay. So since it's stateful, it's really hard to horizontally scale. Okay. Does that mean you cannot horizontally scale? No, it does not mean that. You can write WebSockets you can persist the sockets. You can write smart application to use a third, like a database service, like a Postgres, to kind of persist the connection IDs and have numbers in them, and then you read the connection, and then you have to maintain the state in the database. And even if the database died, it will just, if the server died, it can read back all the connections from the database and do smart thing and reestablish those, right? If you want to, right? It's still not easy. The client has to be written in a way to do the statelessness thing. Okay, it's not impossible, but it's very tricky. Okay, so that's essentially pros and cons. Do you have to use WebSocket, guys? Do you have to use it? No. Okay, I know. All right, it's a cool technology, but doesn't mean we have to use it. Okay, it really depends on what you're trying to do. Right. The question is like, do you absolutely need bidirectional communication? That's the rule of thumb. I just came up with that, right? So if you want the server to send you information and the client to send information to the server, like gaming, absolutely, it's cool. You can use WebSockets. But if you only want like request response, like you're hosting a web page, don't use WebSockets, right? Because why just use a normal, beautiful, stateless HTTP, right? That's why HTTP survived this long, because it's so beautiful and simple. Simplicity rules, guys. Simplicity rules. Okay. WebSockets also simpler, right? But still, it's more more complex than HTTP, right? So if you absolutely need to move to bidirectional communication, that was a terrible British accent, I'm sorry. So if you absolutely need to move to bidirectional communication, then you use WebSocket. But there's still stuff that we invented, guys. There is long polling. Okay, I don't think I made a video about long polling, but essentially the client can send a request and just wait until the server has information, okay, to essentially to avoid this messes, right? If I want to make a request to get the data and the data is not available yet, you can use long polling. It's again tricky, but the server will not send you information until it gets some information. Kafka uses long polling, and they have good reasons about that. Okay, because WebSockets, the problem with WebSocket is the server doesn't know that the client has disconnected as well. It's just like it's like really weird to push data to the client if you don't know if the client is there or not. You cannot assume that. You can use the socket connection, obviously, to tell you that, but you cannot rely on it. Okay, long polling is one. Event source is another thing. I'm gonna make a video about it, but it's pretty cool. If you want just the other way, you want the server to always send you information like notification. You don't have to use WebSocket. It's the one way, but the other way. It's the server sending you a request all the time. Okay, you can send client server, but the server always pushes you information if there is data like notification or push notification. That's perfect, and you can use event source. So it's like the other way. Okay, long polling is just, hey, give me information if that's available, but event source is really powerful stuff. So we're gonna make a video. But most use cases you can solve them with event source. Okay, except chatting, right? I mean, even chatting, you can solve it with event source, because if the server receives information, just send it to me, okay? Right, so complexity versus simplicity, guys. Okay, summary, what we have done, what we have learned in this video, guys. We learned HTTP, okay? We talked about HTTP, the basis of all things, the simplest protocol ever, the most beautiful protocol ever. And then we talk about WebSockets, this bidirectional full duplex thing, right? We talk about that. We talk about the handshake, which is the upgrade protocol, switching protocol 101 code. We talk about use cases, real-time, live feed, right? You don't have to use WebSocket, but you can use them for that, right? Really think hard about use cases, guys. Now, example, we've written a Node.js application that is a web server, essentially, a WebSocket server, okay? The client was so simple, it was just literally 3 lines of code, and we did not even open Visual Studio Code to write that code. We wrote it in my Chrome browser. How coolish is that, guys? Say with me, it's coolish, okay? It's very coolish. So there's a difference between cool, there's not cool, way at the bottom, there's cool, way in the up, and coolish is a little bit below cool, right? It's almost cool, but it's just coolish, right? It's the ultimate state of the mind you want to reach. You want to reach coolish. You don't want to be cool, right? You want to be coolish. So WebSocket, pros and cons, we talked about all that stuff. We talked about when do you use WebSocket. All right, guys. If you enjoyed this video, give it a like and share it with your friends. And hope you really enjoyed this video and you learn. And subscribe to learn more about software engineering, to become a better software engineer. And I'm going to see you in the next one. You guys, leave me a comment below if you want to learn anything. If you want a new video about anything that is in your mind, I'm going to do some research and talk about it if that interests me, right? All right, guys. You guys stay awesome. Gonna see you in the next one. Goodbye.
What is going on, guys? My name is Hussein. In this video, I want to talk about how you scale WebSocket connections, guys, to run on multiple servers. And I'm going to show you how first illustrate that, how WebSocket works. I am going to illustrate how you scale WebSocket connection with a reverse proxy such as HA proxy or Nginx. And once we do that, I'm going to show you exactly a demo or some code that I wrote that simulates a live chat application that is scalable with Docker, right? So I'm going to spin up a little bit of multiple servers with multiple WebSocket servers and one Redis connection and one reverse proxy, and we're gonna distribute all this beautiful connection WebSocket-y stuff, and that's gonna be fun, right? How about we do that, right? You can skip to the code part if you're interested. I'm gonna put the jump code below. With that said, let's just jump into it. All right, guys. So a WebSocket connection, here's how WebSocket connection works. I made a video about WebSockets. Go ahead and check them out if you want details. But in a nutshell, if you have a client here and you have a web server, that's a normal web server, the first thing that the client does is it tries to establish just a normal HTTP connection, and it does, hey, I want to do a GET request, but that GET request has something very special in it. It has something called the upgrade header, right? And that upgrade header is like, hey, web server, I know we just established a TCP connection for the HTTP session, but is there a chance I can upgrade that to WebSocket? The server says, wait a second, upgrade WebSocket? Yeah, I do support that, right? Go ahead and let's use this connection for WebSocket from now on.
আপাতত তো এখানে সার্ভারের চলছে ওইটা, তুই যেটা লিখলি।
Now on. That HTTP session is now hijacked just for WebSocket. Now, this is only true for HTTP 1.1. This is not true in case of HTTP 2. HTTP 2 a little bit more nuanced. The one stream of HTTP 2, almost like one
thread of HTTP 2,
mic down.
right? The stream will be used for
Headphone
WebSocket connection because it will be just a waste to waste the whole TCP connection just for a WebSocket, right? But that's another topic for another day. All right. So what we're gonna do is like the server now can send information just
এখনো দুটো দুটো আছে, বাট ওয়াই?
randomly to the client. The client can send information to the server. It's just a bi-directional thing, right? And that's how WebSockets generally work, right? So it's a very stateful thing. So we're aware of this connection. We are aware of this connection, and the client just sends information to this connection. It checks the state of the connection, right? So how do you scale something that is stateful, right? With HTTP, it's pretty simple, right? Because it's just make a request to the reverse proxy, and the reverse proxy can load balance and hit that request to any web server at the backend, and they will be able to serve us. But WebSocket is a little bit different, right? So let's take the same example with WebSocket. And here's what we're going to do. I am going to simulate 3 clients. The first client is the red client, right? We have red. Here's what we're going to do. We will have some sort of a reverse proxy here and listening to certain port, let's say 80 or 443, probably 443 for security reasons. And that reverse proxy will establish the connection on our behalf to the backend server. So these guys are the WebSocket servers now, right? WebSockets, right? So these are the WebSocket servers. So how do I scale? Here's the interesting part here. If the first client made a request and says get upgrade, right? That reverse proxy, if it supports WebSocket, and there's a big if, not all reverse proxies support WebSocket connection. So you need to find someone that does, right? So I know HA proxy does, Nginx does, and I think I'm not sure about the rest, right? So now we have a request here, and it checks. The reverse proxy says, oh, you want to upgrade the header, huh? I know how to deal with this. Let me just a second. Let me connect to one of the servers, and let's say the load balancing algorithm is round robin. So it's going to connect you to this server, and now there is one TCP connection between the reverse proxy and the backend server, and there's one TCP connection between you and the reverse proxy, right? But since this is WebSockets, right, protocol, that reverse proxy will act like a layer 4 proxy. So it will stream every single packet that you send from now on to always go to this server. That's it. That there's a dedicated TCP connection to this client. So it's like an almost act like a one TCP connection, but it's really not. There are some implementation that where this is physically one TCP connections, where this guy acts like a gateway, just like a router, but this is outside the scope of this video. But let's just say for simplicity, you understand that, right? Okay, let's pick my second beautiful yellow client. My yellow client here now makes another TCP connection. Well, wants a WebSocket, right? So that reverse proxy will say, okay, round robin, the first request was to this guy, so now the second request goes to this guy, and so on, right? So let's just go the blue guy, this guy, this is the WebSocket connection. So now let's just simulate what would happen here if I start sending requests, right? That's what will happen. If I start sending, so let's say the server starts sending information to the client, right? So we'll start sending information. The reverse proxy will say, oh, wait a second, this is part of this, so it will link it somehow to this, right? So it's like almost like one connection. Any request that you send will go to this client. Now this client, if it sends information to that TCP connection, it will go through that pipe, right? And let's say the client, the yellow client now sends information here. It will go through this, and the blue will go through this, right? So frequent request will not be load balanced. That's what you need to understand with WebSockets, because you cannot just, the yellow client suddenly jump to go to the other server, because there is state here, guys. There is state that these guys agree on. Like if you're building a chatting application or a game, there is a state that is here. You cannot just abandon that state and just jump to another one. You can, but it's really, really hard to build, right? It's almost impossible to do that, right? So you do that, and that's the idea. That's how you scale WebSocket connection. So this guy's acting essentially as a layer 4 load balancer, but the configuration is technically a layer 7. Because why? Because this guy actually looked at the header and says, "Oh, this is upgrade connection. How does it know it's upgrade?" It looks at the header and sees, right? So I'm omitting a lot of details, guys. I know this guy is a TLS terminator, where it actually has a secure certificate serving the certificates, but at the back end you can either be secure or insecure. It's really up to you guys. All right guys, to the fun part, the coding part. So I'm gonna spend a few minutes explaining the architecture of the application, the live chatting application that I built, and then we will essentially just show you the code. How about we do that, guys? All right, so here's what I have here. I have a Redis instance here, right? And I have the same thing, these guys, WebSocket servers, right? It's a bunch of WebSocket servers. And this is the reverse proxy, which in my case, it's HA proxy. And these are the clients. So these clients want to communicate with each other, right? They all entered a lobby and they want to start chatting with each other. So that's the application. So the red guy connects, obviously, which will obviously be streamed to one of those servers, and that's it. Now one TCP connection, almost like a logical TCP connection between the client and this server 1. Okay, let's take the second client, which is blue in this case. Communicate, hits the second server, and the final client is the green client. So this guy connected this guy, and this guy connected this guy, right? And that's absolutely fine. So the first problem here, if this guy started to send chat messages, says hi, right? How do this hi propagates to this guy and this guy, the client number, these two clients, right? These are completely different servers, guys. So here's what I did, right? I used Redis as a pub subsystem in this case. I know I talked about Redis, guys. Check out the video I made about Redis and WebSockets. I really generally encourage you to read about these backend technologies. Really pretty cool technologies, right? I'm gonna use another color here for the backend, and here's what I'm gonna do. I use the PubSub technology, and we talked about PubSub in this channel, guys, right? And what we're gonna do here, I created a channel called Live Chat, right? And I made all these guys, when they spin up, I made them subscribe to this Live Chat channel, to this channel, okay? And what does it mean to subscribe? That means if someone publishes something to this, those three guys will see it immediately. And here's what we're gonna do. So this client sends a message, says hi, which will be transferred to this guy, which then is responsible to publish the hi message to the live chat, which will, the Redis code will trigger, and it will say, okay, who's subscribed to the live chat? Oh, this guy, this guy, this guy. So this guy will get it. This guy will get it. Also, this guy will get it as well. And what will happen is like, okay, there will be code that will say, whenever we receive a message from the channel, go ahead and push it to all my clients. So in this case, hi will be transferred back to everybody. So well, this is the client. This client will get the message. This client will get the message. Also, this client will get the message because we'll just get his message back, right? Because we don't know, right? We just subscribe and the message will be distributed to all of these guys. How about we actually show you the code? That's the most fun part. It's really simple because I just use Docker for the whole thing. That's it. You just need Docker and Visual Studio Code to write the code. How about we jump into it? So here's the code, guys. I'm gonna go through the Docker Compose, and guys, you might say, what the heck is Docker Compose? Check out the video I made here on microservices and how to spin up all this stuff. So the first thing is the load balancer, which is this puppy, right? And I'm gonna use HA proxy, and I talked about HA proxy in this channel. Go check out the course I built on HA proxy. And we're gonna listen import 8080. And here's the HA proxy configuration. We'll go through that. And what we're building here, we're spinning 4 or 3, actually 4, how about 4 WebSocket servers, right? And the WebSocket logic server is actually in this image, which we are about to show. That's the code we written that connect to this Redis instance and publish and connect and send information back. All this logic lives in the WebSocket server itself. And I'm just sending some app ID here so we know which server we're connecting to. It's just mumbo jumbo, nothing fancy here. And then finally the Redis server that does all this magic, right? And here's the host names. These are host names essentially. Okay. And now let's go to the HA proxy configuration. The HA proxy configuration, you see large timeouts, and these are very, very critical because the HA proxy will terminate the connection if nobody's communicating for X amount of time, right? And we don't want that because this is a stateful connection and there will always be some people not sending messages for a long time, right? So we need to keep this connection open. So what we need to do is configure a backend, and this backend will have 4 servers. Server WS1, WS2, WS3, WS4, listening on port 80, right? And this is just like logical server names that is for the configuration. All right. What is the final piece? The Docker file, which will build our application. All right. This will be building a Node.js application that will have the WebSocket server, which we discussed in another video, right? How to build it. And this is the Node.js application itself. We are using HTTP module. We're using the WebSocket module. Obviously, we need Redis as well. And we're taking the app ID. And here's what we're going to do. We'll create 2 connections from the WebSockets, a subscriber connection and a publisher connection. And that's too bad because I don't like this. But I guess this is just the limitation that the Redis team have, right? Because this is what we're talking about. Because this guy is also a publisher and a subscriber, you need 2 TCP connection. And the reason is the moment you subscribe, you cannot publish on the same TCP connection for limitation reasons. Obviously, Quick will definitely solve this problem. I have no idea if Redis team will ever move to Quick, but that's definitely one solution, right? There will be 1 TCP connection, well, UDP in this case, but a stream will be reserved for a subscriber and another stream will be reserved for a publisher. I think that's a great solution. RabbitMQ came up with the idea of channels, so I don't know why the Redis team can also implement that. Channels in the TCP. Right, so they need to augment the REST protocol to do that. Anyway, so sorry about guys. I just ramble a lot when it comes to these technical details. I love this stuff, guys. All right, so we have publisher and subscriber for each one. On subscribe, if someone subscribed to you, just immediately publish a message. That's just garbage. There's nothing really special about this. But if I receive a message from the subscriber, this is this way, right? If I'm going this way, right, from the Redis to this, if I receive a message, go ahead and loop through every single WebSocket connection that I have and send that message to my subscriber. So in this case, I'm going to send it to the reverse proxy. The reverse proxy obviously is smart enough to send it to the right client, right? Because it's all this logic lives in the probably the NAT, right? Network allocation table. I might be wrong there. And we're subscribing to the live chat and on the Redis server. Okay. We created, this is just a WebSocket logic connection. We created a bland TCP connection and then inherit that logic in the HTTP server. Listening on port 8080. That explains why we have all bunch of 8080s here, right? And on request, this is the connection upgrade. If I am open, close, do this event. If someone just sent me a message, do this, right? And publish that message to the Redis server on the live chat channel. Channel is very overloaded, huh? Channel on RabbitMQ means completely different thing than a channel on Redis. All right, so set timeout, obviously. And this is just a timeout that whenever your connection, after 5 seconds, I will tell you, hey, you're connected to server 1 or 2 or 3. And then you can, as obviously, have many connections. So I'm going to add these connections to a pool of connections array that I have here. And that's it. And that's the client code. How about we actually test that thing, guys? So to do that, we need to do 2 things. Let's clear all my previous attempts here. We're going to do docker build -t ws app. Is that what I called it? ws app. That's the image, right? So ws app and then dot. This will build the link. That's the first thing you need to do. Build the Docker image for the WebSocket. And we'll build it from basically from this guy, right? The second thing we need to do is docker compose up. That's it. That will start spinning up all those beautiful WebSocket servers, all those beautiful HA proxies and Redis and everything. So it looks like we're up and running. How about we start testing this thing? I'm going to open a brand new Chrome. I'm going to go to the developer tools, clear that thing. And here's what I'm going to do. Const, let's zoom in here so you guys can see. WS, I'll just say WS because I'm going to do this a lot, obviously. Equal new WebSocket. WS, localhost, because it's running on my machine, right? And it's exposed, right? That's it. And then I just connect it to the server. We need to set up the message, obviously. And then finally, we need to start sending. So this is client number 1. I'm going to say, hello, I'm client number 1. Okay. And immediately I got the same message. Obviously, we have one client. So we just need to do this all over again on another client. All right, guys, let's do this again. All right, guys, now I open 2 Chrome views here. I'm going to establish a connection right here. And then I'm going to wire the message. And I'm going to send, hey, I'm client number 1. Immediately I got it. And the 5-second immediately got it. Oh, you connect to server 4. Right, by the way, this is all round robin. But let's check. Now I'm going to connect from client 2 here. All right, and send I am client number 2. I'm connected to client number 1 in this case, all right? Look at this. We got that message. Now if I do ws.send message, another message. Immediately I got it here, and I got it here, despite us connected to different servers, right? And you can scale this to as many as you want. I can open many servers, many web pages like this, and I start playing with this thing. And I want you to play with this thing now. So now if I send a message from here, if I do ws.send, hey, immediately I get it here, and I get it here, despite me and the other client on a completely different server, because we just proved it, right? We were connected to server number 1 here, container number 1 to be specific, and this guy's connected to container number 444, and we communicate together with the power of Redis, right, in this case. All right, guys, and final thing before we end this video, guys, yeah, obviously we have Redis as a kind of a central point of failure here, but Redis supports clustering and replication to allow us to scale, right? So what you're going to do is like spin up multiple Redis instances in order to essentially scale that. But I rarely, really doubt that you're going to need that, except you're going to have thousands and thousands of connections. Scaling just this layer is enough to me to scale WebSocket connections. All right, guys, so that's it for me today. Hope you enjoyed this video. WebSocket, have a great weekend. I'm going to see you in the next one. You guys stay awesome.